Hello, everyone, and welcome to Python First Steps, Modules and Packages. My name is Karina Lapointe with O'Reilly. I will be your facilitator, and your instructor for today's course is Reuven Lerner. Reuven is a full-time Python trainer teaching courses worldwide. He created one of the first 100 websites in the world just after graduating from MIT's computer science department. He opened Lerner Consulting in 1995 and has been offering training services since 1996. Reuven's monthly column appeared in Linux Journal from 1996 until the magazine's demise in 2019. He's a panelist on the Business of Freelancing podcast and previously spent 5 years as a panelist on the Freelancer Show podcast. Reuven's most recent book is Python Workout, a collection of Python hands-on exercises with extensive explanations. His free weekly Better Developers newsletter about Python and software engineering is read by more than 15,000 developers around the globe. His Trainer Weekly newsletter is similarly popular among people who give corporate trainings. To learn more about Reuven, you can click on the speaker bio widget. And speaking of widgets, I would like to go over a few of them before we get started that will help you get the most out of today's online training. You will see a series of red icons at the bottom of your screen, and this is your widget tray. If you click on the icon, the window will appear on your screen. We will use the group chat on the far left, and that's how we'll communicate with each other. You can reach out to me there if you have any audio video issues, and you can also communicate with each other. On the far right, you will see the Q&A widget, and this is where you should post your questions to Reuven anytime during class. For your convenience, you are able to resize, minimize, and move the widgets around to your liking on the screen's real estate. We are recording the course and we'll have it ready within the next 24 to 48 hours after completion of the class, and you will be notified with an email as soon as that recording is available. You can also use the link you used to enter today's class to view the recording. So I suggest that you take a moment and bookmark the link. The group chat I mentioned earlier is part of the class recording, so we ask that you not post any personal information, such as your email address. And with that, I'll turn it over to Reuven. Enjoy your class.
Hi, everyone. Welcome one and all. There we go. So welcome to yet another Python First Steps class. This is one of a series of courses that we're doing for people who don't have that much experience with programming and then also don't have that much experience with Python and who want to, well, as the title says, take some first steps with the language. And today's class is all about modules and packages in Python. So what are we going to be talking about? Let me put up a quick agenda here. And by the way, just so you know, I don't use slides when I teach. I'm mostly going to be using the Jupyter Notebook for today. And this is replicated on the GitHub repository that is in the resources list for the course. So about once a minute or so, worst case, once every 2 minutes, it's automatically going to be uploaded there to GitHub, and you can take a look at the notebook there. I'm also going to be creating some files. Those are also going to be in the repository, and those will be replicated there automatically. And that repo will be available not just while we're doing the class today, but basically forever. I don't plan to take it down. So after the class is over, you can feel free to take a look at what's there, download it, clone it, play with it, and so on and so forth. So what's the agenda for today? Well, first of all, we're just going to talk about, what are modules? Like, why do we want them? Why do we need them? And how do we import from a module into Python? And then we're going to talk a bit about, different types of module or different types of imports. Then we're going to talk about how we can create our own modules. And we're going to sort of go back and forth today between importing things that already exist. And believe me, there's a lot that already exists that comes with Python and what's known as the standard library. We're going to talk about that. So we're going to talk about creating our own modules and how that works and what's involved with doing that. We're going to look at, indeed, the Python standard library. We're going to talk about packages versus modules, which can be a little confusing, but it's important to understand what's going on there. And then we're going to talk about not just things on our own computer, we're going to talk about stuff on foreign computers. That's, say, downloading and installing stuff from PyPI, the Python Package Archive. We're talking about PyPI and installing things. We're going to talk about pip then as well, pip command. And I think that should pretty easily take us through the time that we have. I want to say I love to get questions. From my perspective, my work is interesting because I get to interact with people around the world, get their really interesting questions and try to answer them. Usually I can answer them. Sometimes I have to do a little homework in order to do that. But so please don't hold back. If there is something that you don't understand, something that's not clear, something that I messed up on, don't feel free. Don't hesitate to get in touch with me. I'm hoping that my sound is okay. If not, we will figure that out. But should be okay based on what we were checking before. Let me try just in case to. I don't think there should be any problems, but let's just hope. All right. Yay. Phew. Thank you for those answers, folks. So please submit questions, submit comments, and just like that one, and we'll be able to interact and have a great time. I'll also add, because this is a First Steps class, I hope people are extra okay with asking questions. Sometimes when I'm teaching classes, people are a little embarrassed to ask because they're like, well, I don't want to hold other people up. That is the whole purpose of these First Steps courses. The whole purpose is to ensure that everyone has a chance to really learn from the ground up. So, what, why, and how? Okay. Chaos asks, are the slides going to be shared in the resource list? So there are no slides, but the what I'm doing. Oh, I didn't share yet. Sorry, I forgot to share my screen. Usually I'm bad about unsharing the screen. There we go. So now you should be able to see. And this Jupyter Notebook is being shared indeed in real time with you on the GitHub repo that you can see in the resources list. So hopefully that will be available. If you can't find it, then just double check with us and we'll show you where it is. So the first question is, what are modules? And in order to talk about modules, we have to understand a few other concepts. So first of all, one of them is my favorite term, dry. Don't repeat yourself, which I first learned from the Pragmatic Programmer book. But it might have come before that, it might come from other places. And the idea is that when you are writing code, you don't want to repeat yourself. Now, I don't know about you folks, like when I've written code, and this happened to be dozens, maybe hundreds of times over the years, I say, oh, what are the odds? What are the odds that if I repeat this code, it'll actually cause me problems later on and I'll have to modify it in more than one place? And the answer is 100% of the time. If I repeat my code, I will, be dealing with that pain down the road many, many times. So what do we mean when we talk about don't repeat yourself? Well, if I have the same code several lines in a row, then I can combine them into a loop, right? So instead of having the same code or almost the same code again and again and again several lines in a row, I can just do a loop, a for loop, a while loop, and then I don't have to write it many times. I can just write it once, modifying maybe the variable with each iteration. If I have the same code in several places in my program, then I can write a function. And that's really important also because it means that I can take code that is happening in multiple places, abstract that into one function, and then just call that function many different times. And that allows me really to not only clean up my code and make it more efficient, but to think at a higher level as well. But what if I have the same code in several different programs, then I need a library. And this is common to just about every programming language out there. The idea is that I am likely to do the same things in many different programs. Think of the things that we do with our computers, right? We open files, we want to print things, we want to send things to the network. All these things, if every single program out there needed to re-implement this stuff again and again and again, we'd be in a terrible place. In fact, I remember when this was the case, when I was growing up, and when we would buy a word processor, the word processor actually would say, this word processor only works with the following printers. And so you had to make sure that your printer and your word processor worked together. A number of years later, this was basically a solved problem. Why? Because all the major operating systems, certainly the Mac and Windows, all the major operating systems basically said, we are going to provide a library of printers to all programs. And no longer do people need no longer does every word processor, spreadsheet, presentation program need to deal with a printer on its own. Rather, they'll be able to deal with it through a library. And the library knows how to deal with all the different printers that are out there. And so we were able to improve our code and also crush it down quite a bit in terms of how long it was. So libraries are really useful and really important. But there's another thing, as you're going to see, that modules provide us with. So in Python, we call our libraries modules, right? And a module is actually a type of Python object, as you'll see in just a little bit. But basically, Python modules do what other languages would call libraries. But modules provide us with something more above and beyond that, right? Modules also provide us with namespaces. And a namespace is really important, even though it sounds super, super boring. And the idea is as follows, and we're going to see all this again and again today. I'm just sort of setting things up. So imagine if I am working with someone else, maybe on your team. You and I are working together on some project, and I'm working on my file, and you're working on your file. And both of us happen to use the same variable name. And then we want to join our files together. Bad news, right? Because if I use the variable name X and you use the variable name X, and by the way, neither of us should be using the variable name X, but if both of us are using the same variable name, then there's going to be what's known as a namespace collision, meaning that someone is going to win and someone is going to lose. And the winner from within our little namespace collision doesn't matter because it's the user who's going to lose and our program is going to do all sorts of horrible things. And so a module allows us to divide the world into different namespaces. You can think of it sort of like having surnames, last names in the real world, that it allows us to divide families up, people up, so that we don't confuse them as much and as often. And so modules really do an awful lot for us. The other thing to remember before we start looking at modules in detail is modules in Python are really simple and straightforward. And I hesitate to use those terms because when I say something like something is simple and straightforward, inevitably someone doesn't understand that it feels bad. So let me qualify it a little bit. Compared to just about everything else in Python, modules are simple and straightforward. There's not a lot to learn. There's not a lot to concern yourself with. It's very thin, limited overhead to give us a lot of functionality. That said, modules in Python also don't do some of the fancy things that they do in other languages. So we are missing a little bit. And things will get a little complicated when we start dealing with the internet and PyPI and pip and installing stuff. So there, we may get into some complicated things. Once again, if things aren't obvious to you, please don't hesitate to say so. So, okay, so this is all very nice and everything, what modules are and what they can provide me with. But let's take a more concrete example. I want a random integer between 0 and 100. Let's say that I want that. So how could I get a random int between 0 and 100? Well, the hard answer to that problem is to go create a random number generator on my own, write a program that will do it, and then use that random number generator. Fantastic. Except guess what? Random number generators are notoriously difficult to write and to get correct. They are really, really annoying. I would never trust myself to do such a thing. Fortunately, I don't have to. So if I want to get a random number, I can use the random module that comes with Python. Now, we're going to talk more about the standard library that comes with Python a little later, but you should know that random is one of those modules. It comes with Python. It's in the standard library. And so how can I use that? So to load the random module, I'll use the import statement. Okay, here we go. Import random. Ta-da, and it's done. Now, this raises so many questions already. I've only written two words of Python, and already we've got a whole lot of questions. The first thing is, hey, wait, where are the parentheses? The second question is, hey, wait, where are the quotes? The third question is, so what's going on here? So let's then review all of this. I mean, 2 words, and we've already got a whole host of questions and so forth. So let's see how to review this. So the import statement, right? It is not a function. It is a statement, or if you prefer a keyword, it's built into Python. All right, and it is not a function, so we don't use parentheses with it. It's wrong to say import parentheses and then the name in those parentheses. You can't do that. You shouldn't do that. The name that you give, as an argument, I hesitate to use that term, but I'll say it anyway. to import is the name of the module that you want to define. Huh? What am I talking about there? So when I say import random, I am basically saying to Python, I want to define a variable of type module called random, right? So in this code, I'll just write this down here. So in the above code, I told Python to define a new variable, random, define a new variable which will refer to an object of type module. Now that sounds a little weird, but that is the most sort of accurate, technically correct way to describe it. But that raises some questions as well, like what do you mean define a new variable of type module, right? So it turns out, if you know anything about defining functions in Python, so when I define a function with def, if I say here, for example, def hello name, return hello name. If I define a function, I'm really doing two things. I'm creating a function object, and I'm assigning it to the variable hello. Yeah, hello is a variable just like any other variable. It happens to be a variable that refers to a function, but it's a variable. So when I use import random, I'm doing something similar. I'm telling Python, I want you to create a module object. I want you to assign it to the variable random. So far, so good. But wait a second. When I'm defining a function, I'm basically taking, I show it the function body, right? Where is this, where are the contents of this module object, which we're going to create and assign to random, coming from? We will talk about that in just a moment, where it comes from and how we can look at that and how we can sort of play with it. But you should know that it's basically coming from a file, that when I say import, I am telling Python, go look for a file. I'm telling Python to look for a file named random.py. Now, that's not 100% true, but it's pretty close to true. It's true enough for our purposes now. So random here is not a string. It is not a file name. It is the name of the variable we want to create, and coincidentally or not, the name of the module we want to create is sort of associated with the file of the same name with a .py after it. Oh, and VS asks, how many files consist in the random library? So let's try to like sharpen that a little bit. So the random module is a single file. However, that file contains many different definitions of functions, definitions of data, definitions of classes. I should also add that the random module plays some tricks and plays some games so that it'll work in a certain way. So it's like an auto-creating object in some ways, which is super weird, I must admit. Like, maybe it's not the best example, but it's an easy one and a fun one to work with. Okay, so now that I've done that, right? So after I've created my after I've imported random, what do I have? So let's check. First of all, if I just say now random, this is known as getting the printed representation of an object in Python. And this is one of the things that Jupyter is great at. If I just type the name of a variable, or any object, I get the printed representation of that object. So random, being a variable, will show me the printed representation of what's referring to, meaning the module object. So we see here it's module random, and it was loaded from this monstrosity of a path. User, local, seller, Python, blah, 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 blah. That's because I have installed Python on my computer using something known as Homebrew. And so Homebrew puts things in this user, local, seller. NK asks, can I have a variable name different from a module file name? Yes, you can, and we're going to see how to do that in a little bit. Absolutely, we can. We can play all sorts of games. But because there is such a tight connection between module names, the file names, and the variables, I'm going to call it three things, even though it's only like two things. Because of the tight connection there, modules must have names that are legal Python identifiers, meaning legal Python variable names. If I were to somehow have a file name, AB-CD, right, that's not a legitimate Python identifier, and thus it's not a legitimate Python module name. And we're going to, when we define our own modules, then we're also going to see how we can name them and how we can work with them. Okay. So there I've got random. If I say here, hey, what's the type of random? Well, it's a module, right? So just as, and I can say, what's the type of hello? Type of hello. and hello is a function object. So everything is an object in function. Everything is object in function. Everything is an object in Python. And so we have objects of type function and objects of type module. And the fact is that an object of type module doesn't do that much. All it does is basically handle loading of itself, and even that it kind of outsources to someone else. And it also basically just acts as a container for other things. So if a module is a container for other data, what does a module contain? Well, let's take a look. Does every module in Python consist of a single file VSS? The answer is no. There are some, well, technically speaking, yes, but every module object can consist of one file or more than one file. We're going to see later when we're talking about packages how it can be more than one file as well. That gets a little more complicated, but we can totally do that, and we will. So in order, the names defined or the things defined on a module are available as attributes. What does that mean? Every object in Python has attributes. They are the things after dots. So if we have a.b, then a is a variable and b is an attribute. An attribute of a. And by the way, some people coming from other languages believe that if we've got a.b, then b must be a method, right? It must be some sort of function that we can call on a. And it is true that methods are attributes, but so is data, right? The fact that we have a dot there does not mean that it's necessarily a module. It's not necessarily a method. So basically, if I know what is defined on the random module, I can just say random dot something. But how can I know what's defined there? Get a list of attributes on an object with dir. So the dir function will return a list of strings showing us what attributes are there. So if I say dir on random, we're going to see a whole bunch of things here. Now, some of these are more interesting than others, right? And I don't mean interesting in the sense of what's on the random module. So some of these, like the things with capital letters, those are typically going to be constants. Now, Python doesn't really have constants, but it does have things that we are discouraged from changing. So, I mean, we can change things, but we shouldn't. So these are going to be some constants. Here, we're going to have things that begin with a single underscore. Single underscore means this is private. Do not touch. We have things with double underscores. Those are known as dunders in Python. Those you shouldn't touch either. A few more private things. And then, now we have a whole bunch of other stuff. And those can be functions, those can be classes, those can be methods, those can be data. There's no way just from looking at it to know. Well, okay, then how am I supposed to know? Well, what I can do is I can say help on my module, help on random. And now I'm going to get documentation on it. Look at that. It'll give you the help. Now, we are not going to read through the help here, but you should know that when you are working interactively with Python through Jupyter, I use help all the time, and modules are typically documented pretty well, especially stuff in the standard library. And you can go through and read all about the modules and classes and functions and data and you name it, right? There's way more about random stuff than I ever would know in my life. So you can also go, by the way, to the Python website where there's documentation. So if I go to the Python standard library here, oh, I didn't want that. Well, okay, I'll just drag it here into the screen. Bloop, 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 bloop. There we go. Let me just get rid of this thing. All right. So here, if we look at random, and we're going to come back to this later and look at the standard library, you'll see here it's more nicely formatted, easier to work with. You can look through it. And at the bottom, it typically has examples as well, which can really come in handy. Okay, so great. So I've loaded up random. I've seen there are lots of things there. And, right, if I want to generate a random integer from 0 to 100, I can use random.randint. So I say here random.randint 0 to 100. And look at that, I get a random number. Well, it seems to be a random number, right? Let's run it again. I could run this all night, right? And over time, we will see whether it's really random or not, sort of. I'm, again, not a mathematician here, but my impression is that it's pretty close to random, if not completely random. So there you go. What I've done is I have imported the random module, and I've called a function in that module, passing it arguments, and I get a value back. This is way better, way easier than me defining randint all by myself. All right, questions or comments so far? And by the way, I really appreciate that people have been asking questions all along. I just want to make sure No one's lost. If anyone has any questions, we'll give you a few seconds to ask. And then we'll try a short exercise to play with this stuff. And then we'll dive deeper into all these things. Whether it is importing things, modules, where they're located, the whole 9 yards. All right. So no questions so far. We'll have to make it harder, I guess. Okay, fine. So let's try a short exercise just to sort of, start flexing your muscles in this direction. And let's say here we're going to, import and use. So PG asked a great question. Random is the module, random is the function. Yes, precisely. So random is the module, which we defined with import. And randint is a function in that module, which we access as random.randint. Okay? Do we use the underscore items? We could, in theory. If you import random, then you have access to the underscore items. Typically, traditionally, a single underscore before the name means it's private and you shouldn't mess with it. That said, what do we have here? We have like pi and e. I'm going to assume, I've never actually used these, but I think I can guess what pi and e are, right? So if I say random.pi, oh, no, it's underscore pi. No. There we go. So if you ever want to know what pi was, now you have it. I thought it was longer than that. But anyway, and e also, there you go. So basically, random, MK is saying random is the variable pointing to module random. Yes. So basically, random, like all variables in Python are actually just referring to an object. So if I say, for example, let me just show this to you. If I say x equals 10, x, the variable, actually refers to the integer object 10. If I say y equals 10, 20, 30, y, the variable, refers to the list object 10, 20, 30. So in the same way, when I say import random, random now is the variable referring to the module object random. It's very consistent here. Will random generate the same number after 100 plus runs? Good question, SK. So basically, in theory, a random number generator could give us the same number each and every time. It shouldn't, right? It should give, but in theory, it's random. In actuality, it's a little more complex than that because getting true randomness from a computer, which is deterministic, it's kind of hard. So they do all sorts of wild, crazy stuff behind the scenes. And I'll even go further than that. If I say random randint, let's do this. Print random randint from 0 to 100. I'll just do this 3 times. For I in range 3. Print random randint 100. All right, and if I were to do this again, it's going to give me 3 different numbers. Or, it will. But, because of the way that random numbers are generated in Python, we can actually say random.seed 0. What this means is restart the random number generator with a seed of 0. And what that means is then, after we do that, then we're going to get the same 3 numbers each time. Right? And sometimes I do this in classes to make sure that everyone is on the same page with the same numbers. What is random seed? Seed is another function in the random module. So this is useful if you want deterministic results, if you're doing testing, for example. Okay, let me say, lots of questions here. Okay, do we use underscore? We already talked about that. Let's see. VS, how can we omit the word random? We are going to get to that in just a little bit. All right, and JP says, can you provide an example of A, B, where B is not a method? Yeah, so how about random._e? That's not a method, that's just data. Okay, and MK is asking, where do we use dunder? So dunder, the double underscore, so dunder is double underscore something. And that typically means a name that Python is expecting to use. Right, it sort of fits into Python's existing protocols and APIs. And if we define a name there, then Python will see it and use it. It's used very often in object-oriented programming. Typically, you don't want to touch the dunders that someone else has defined. And even in your own code, you just want to play with it a little bit. Let's see. So that's what do we use dunder. Let's see here. JP, is it some sort of knockout list? Is it so? Oh, no. Oh, JP, now I understand. No. So it's not. Oh, what a great question. So it's not that it has a list of 100 integers there, and as it goes through each one, it I like that knockout list. So if we go 13, it's not going to do 13 again. No, not at all. It could. Each time it's going to pick a new random number between 0 and 100, irrespective of what it had before and after. Oh, I love that. That's great. And MK says, can we attach multiple functions to an object in the same line? I'm not quite sure what you're asking. You can't, a function is an object, and a variable always refers to one object. So you can have a variable refer to a, or you can have a variable refer to one function, but you can't have a variable refer to like two functions simultaneously. All right. All right. What is the difference between a single dunder versus a double? Okay. So basically, some naming conventions. But basically, identifier. This is plain old variable or function, all lowercase, public, etc. And then if we say here, big name, this is in camel case and should be a class. I should add, these are conventions. These are not rules. And so Python basically lets you do what you want for the most part. So dunder name, this is, is dunder name, and should be defined only if you know what Python expects to do with dunder name defined in your code. We're actually going to talk about dunder name later. And then if you say here, like underscore something, right? This is as private as things get in Python. Don't touch this in someone else's code. And finally, you can actually say like something underscore. This is sort of to avoid namespace collisions with things in Python. So those are the basic conventions that you have there. So this is dunder name, and this is like one underscore at the beginning, which is underscore something. All right, great stuff. So let's try a quick exercise then, right? So I just wanted you to sort of play with this a little bit. So generate random numbers. You know what? Let's actually try something here. So what I want you to do is I want you to import the random module, and then set the seed to be 0, and then run a for. Let's even say here, I'm going to really turn the screws on you folks. Create an empty list called numbers, and then iterate, let's say 1,000 times. Each time, generate a random integer between 0 and 100 and append it to numbers. And after that, what I want you to do is get the mean of numbers. I'm going to hope that none of this is too complicated. If it is, we will go over it anyway. Can you explain something underscore with an example? Oh, yeah, all uppercase is a constant. That's true. That's true. Something with, so like if I want to say like, class underscore equals, I don't know, stir. So example of a trailing underscore, right? So, class is a reserved word, is a keyword, so I can't assign it to something, right? That's what I meant. Okay, so try this exercise now. I promise you, not everyone will be able to finish it. All right, and that's not because I'm trying to be mean or harsh, although that is my personality. But basically, we just sort of got to keep going. So I'll give you a few minutes to work on this. Meanwhile, if you continue to have questions, I will continue to answer them. We'll go over this together, and then we'll move into different kinds of importing that we can do. All right, so keep the questions coming. Try this out if you can. I'll add, by the way, in terms of the trailing underscore, in the data science world, in scikit-learn, which is written in Python, they actually use it for something else. They use it that after you've trained a model, what do I want to say? After you've trained a model, then it sets a bunch of attributes with trailing underscores to indicate, oh, this is what we learned during training. Oh, I see there's one. I see GP had another question. Does random inclusive of 0 and 100, in this case, excluding these numbers? Great question. So you can actually find out. I can say here, or I can find out. I can say here, help on random.randint. And look at that. It says return a random integer in range A, B, including both endpoints. So now I showed you how to get help, and I was able to avoid having to make a guess because I was able to look it up myself. Ha! No idea about lists. Can we walk through it? Yeah. We'll walk through the exercise in a little bit, but basically, just so you know, you can always say like my list equals like an empty list, and then my list and 1, my list and 2, and so forth, and then my list. Then I can not type or spell, and then we have 1 and 2 on there. Yeah, one of the sort of, the good news, bad news things about these first steps courses is that there are a whole bunch, there are 5 of them. And it's hard to know sort of because they're all over the map in terms of like scheduling. So it's hard to know what people have seen before and not seen before. So I'm happy to try to answer questions on that stuff. The point of these exercises is not to make you feel dumb. The point of the exercise is to like try out some of this stuff on your own. I'll give this another minute or two, and then we'll go over together. And again, don't feel bad if you can't finish it. It's really like totally okay. Oh, here we go. MK saying, well, I tried to manipulate lines. Can I use test upper capitalize? Can I use the check? Yeah, so I mean, the whole idea of an attribute is basically it's just an object that belongs to another object. So you can definitely say a.b.c.d.e.f and so on and so forth. And then what's going to happen is it goes to the first variable a and says, hey, do you have an attribute b? Oh, you do? Great. Give us that object. Then we go to that object, say, do you have an attribute c? Oh, you do? Give us that object. Then you have an attribute d, and it'll just go on and on. Now, if you do this with a method, methods actually are objects too, and so they will have attributes as well. But you probably like there's a difference between saying, for example, a.b.c.d and a.b.c.d. Right? These are two different things. Where here, it's the object we get back from calling the function a that will have an attribute b, which will be a method which we'll call, which will return an object, and so forth. And here we're just like traversing through the objects. But basically, modules are just like making use of this, which generally exists in Python. Right? Everything is attributes, and modules are just letting us define attributes based on something in an external file. Okay, let's look at this together. All right, so I'm just going to move this down to the bottom here. All right, so what do I want to do? So I'm going to import the random module. So I'm going to import random, and that loads up the module file and makes it available to me. All the things that are defined there available to me in the variable random. So as of this point, random is defined as a variable. And I'm going to say now random.seed 0, and that means that everyone should have, in theory, should have the same values. And then I can say, create an empty list. So I'll say numbers equals an empty list. So create an empty list. And then I'll say here, seed the random number system. And by the way, you can use whatever number you want, just like why not use 0? And then I'm going to say here, for I in range 1,000. I'm going to say here, numbers append random randint from 0 to 100. And so I'm generating 1,000 numbers. And now what I can do is I can say, well, I want to get the average. So I can say, how do we know the current value of seed? I think you just call seed by itself. It returns it to you. We'll find that in a moment. And then I can say here, what's the sum of numbers divided by the len of numbers? And we get back 48.697. So that looks like a pretty good distribution to me. If I run it again, what do you know? It's the same thing. Of course, it's the same thing because I use the same seed. If I say a random seed, I think about, method, if I just do this. No, it doesn't return it. I don't know. I don't know if we can get a random seed. Do we find out how do we get it? I don't know how to get it. Fascinating question. I don't know. All right, and by the way, if I were to add like another few, like let's add another 2 digits there, right? We're gonna get closer and closer to 50, which means, from what I understand again math-wise, that means we have like a better and better distribution. All right, so this is how we can make use of a module and a function of module so that we don't have to like reinvent the wheel each time. Okay, so someone had a question before, I can't remember who it was, but someone was saying, hey, this is kind of annoying, right? Like, let's say I'm going to be using randint a lot. So I cannot say randint. Why not? Because randint, if I just say it like this, Python says, oh, I'm going to look for a variable randint. Look for a variable randint. But there isn't a variable randint. Rather, there's a variable random that has the attribute randint. So randint doesn't exist on its own. It only exists within the namespace random. So, however, I can load randint, or I can define randint as a variable. I can say from random, import randint. Now, what is that going to do? That means, in other words, import random, import the random module, but don't define the variable random. Rather, define the variable randint, which refers to random.randint. Now, why am I saying this first part, import the random module? Because I was convinced for many, many years that if I want to save memory, then I can just do from import, and from import will guarantee that only the little bit that I'm interested in, only randint will be loaded, and the rest of it will be tossed out. Not true at all. It turns out that the random module is loaded into memory, put into sort of the back end of Python. It's still there, but the only thing that we have access to is randint. And now it's no longer an attribute of random. Now it's a variable. And so now I can say randint 0 to 100, and it works just fine. And why would I want to do this? Because basically it makes our code shorter, easier, and easier to work with. Also, you'll sometimes have things that are really deep in a hierarchy. So it's sometimes nice to be able to say from a.b.c.d import e. And then like if we have this long hierarchy, it just becomes easier instead of writing a.b.c.d each time. Should your code run at the Python prompt? You mean like should my code in general, or this code here, what I'm doing in Jupyter? This should actually work in the Python prompt. If you just type Python, you see like greater, greater, greater. You should be able to type in all these things. It should work without any trouble. All right. So I was my great code in GitHub and using idle or py files. So I'm not quite sure if you find stuff that like, I said, if you find things in a .py file, you should just be able to load that into an editor of some sort, right? I'm a huge fan of Jupyter, but as you're going to see a little later, we have to use an editor to write modules, and that's going to be .py files. And .py files are like the standard way to write Python stuff anyway. So you'll have to figure out a way to do that, and you'll need to find an editor that you like, that you're enjoying. Random mean code, okay? VS asks, can we port all from module with Starlike in Java? Unfortunately, yes, and I will talk to you more about that in a little bit. So PW, something fails with a syntax error. If you can paste maybe what the error is. I know that the pasting looks really horrible when you do it, but give it a shot. What does the seed function do? One is asking. So the seed function basically resets the random number system, so it starts from the beginning. So we know, instead of choosing instead of basically giving us random numbers, it gives us a deterministic set of numbers. So if I do random seed 0, then give me random, 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 it's going to give me the same 3 things again and again in a row. All right, so I can basically load up from random, import random. And by the way, sometimes we'll do both. It's not totally crazy to say import random and then say from random, import randint. What's wrong with doing that? Nothing. Nothing, because here, this is going to define the random variable, and this is going to define the randint variable, and then I have both of them, available there. Invalid syntax. So if I'm looking to, I don't see anything obvious from what you're doing as sum numbers / len numbers. I don't see anything obvious there in terms of giving you trouble, and Terribly sorry. EM, how do you unset seed 0? Well, it's not a matter of unsetting. It's like you can just choose a different number, right? You can say random seed of something else. When you start up Python, it chooses a new random number. Like it chooses a random seed for you. So like if you're using the seed function, it's because I want deterministic semi-random numbers. So that's like, a little easier to deal with. All right. Sorry, PW. Okay. So these are two different ways to load up our module stuff, and it works just fine. C is used a lot of machine learning, deep learning. Oh, interesting. I always thought of it as being used in testing, but actually, I guess almost the same thing. Like you want to seed things in a certain way. All right. So this is nice, and this is good, and these are two very, very common ways to do things. By the way, I can also say from random, import randint, comma seed, and we can import more than one name from a module. Right, so this is pretty commonly done as well. Now, someone asked, I think it was VS, but I could be mistaken, asked, can we, like in Java, say from random import star? The answer is, you can do this, but I will not be your friend anymore. Right, this is just terrible in numerous ways. So why do I despise this so much? First of all, because it's like there's a practical problem and there's a semantic problem. Let's start with the semantic problem. The whole point of having modules, or one of the points of having modules, is to separate things into different namespaces, so that although this is from random and this is from collections and this is from string and if I say from random import star, it's like, hey, I don't need namespaces. I'm just going to make everything a global variable in the same scope. You are in, like, it's just like conceptually, it's a bad thing to do. You want to have that separation. But practically speaking, you are basically inviting Python to create namespace collisions. You're basically saying, hey, whatever is defined in random, I want it to be a global variable now. What happens if random is updated and they define a bunch of new variables? Guess what? Now they're globals in your system as well. And then what? And if you do this with multiple modules, if you say from first thing import star, from second thing import star, wow, you are in for a world of pain, because only the last one will step on the previous one, So I implore you, never use from import star. In fact, just earlier today, like a few hours ago, I uploaded a video to my YouTube channel, like how to foil from import star. And we'll talk about that a little bit later as well, like how if you're writing a module, you can stop people from doing this. I'll also add, by the way, this is especially true for people using Jupyter, because Jupyter keeps the same Python environment throughout what we're doing here. I'm going to end up having to restart my Jupyter kernel a few times, and that's just like wipe out whatever variables were previously defined, so I don't end up with like nonsense and crazy stuff or too much crazy stuff in my notebook. So I'll tell you when I'm going to reset it, but that will basically I'll have to reload everything from scratch, which is fine. Okay, so there are some other ways that we can import as well, and people were asking about this before. So let me just review. So the simplest import way to import. Oh, you failed to import random. Oh, that would do it. Excellent. I mean, sort of. Simple import is just import random. All right, and then import one name from a module. We can say from random import randint, comma seed. One or more names. But here are some other ways we can do it. I can say import random as R, right? So import random, but define a different variable. Now, why would I want to do this? There are actually two reasons or three reasons why you might want to do this. One is to avoid namespace collisions. Maybe, just maybe, there's more than one module with that name, or you have a different variable that you've defined as random. You don't want this to clash with it. Totally fine. Maybe you just want it to be easier to type, right? There's nothing wrong with saying, I want to type less. Although you should all learn to touch type. Like my parents forced me to do it in high school. Most practical thing I ever did. Okay. The third reason, though, is to adhere to conventions. So if you're working in the data science world, then you're probably using NumPy and Pandas. And you could say import NumPy. But I'm telling you, you don't want to do that. Rather, you want to say import NumPy as NP, Why? Because everyone else in the NumPy world is doing that. And I, as a very stubborn person, when I started using NumPy, I was like, I don't need to do that. I type quickly. That's ridiculous. And then I did what all good programmers do, which is I go to Stack Overflow and I want to copy and paste what they've done there. Like, why should I work hard? I can just copy and paste what others have done. And I discovered that literally everyone had done import NumPy as NP, and I was just renaming things. So just just do it if there's a convention there. So that will happen. Another thing you can do is you can say from random import randint. Oops. So we can import one name, but with an alias. So we can say from random import randint as RI, right? And that will basically combine these things. It goes to the random module, it imports the randint function or name or whatever it is, but it defines the variable to be RI. And that's actually really useful if you want to avoid namespace collisions there as well. All right, let's see, any other questions there? Random between 0 and -10. Why does this give an error? Because -10 is an integer. Is it now? Are you sure about that? So let's just check. If I do a help on random.randint, it says here, return a random integer in the range A to B, including both endpoints. So if I say random, a randint from 0 to -10, yeah, it's going to give me an error. And what's the error it gives me here? Empty range for rand range. So what it's trying to say is, hey, I'm trying to go from this first thing to the second thing, and I can't because I have to go up. But if you were to say random.randint from -10 to 0, I'm guessing it would work fine. And sure enough, that works fine. So it needs to be lower limit and then upper limit. And I guess that's implied in the documentation they have here, but not made super, super obvious. So now you know. Okay. Let's check out some of these questions here. Okay. So what we've managed to do now is we've managed to, import a module, use a module, and so forth. But there is at least one weird thing going on here, which is we've never told Python where to look for this module. Like I keep saying it's loading a file. And if I say, hey, random, it tells us it's loading a file. But we didn't tell it where to look. And I even mentioned before that unlike many, many other programming languages, it does not say, we're not giving it a string. We're giving it the name of the variable we want to get. So how does Python know where to look? Well, there's a module for that, right? So basically, there's a very special module called sys. All right, and this module is loaded automatically when Python starts. But it isn't defined as a variable until we import it. So if I say import sys, it's basically the most ridiculously fast operation you can have because it doesn't need to do any work. It's just like, boom, okay, I'm there. I defined that variable. And in something called sys.path. And sys.path, as you can see, is a list of strings. A list of strings indicating where is Python going to look. Where is Python going to look for our module? So what does it do? It starts here in the first. These are considered to be either directories or zip files. Either one is fine. So it's going to look in this first place, which is always defined to be the current directory. So this is the directory which I'm running Jupyter. And this is users, Reuven, courses, current, O'Reilly, first steps, 2021, April 1st. There you go. That's here. That's now if you hadn't guessed. No April Fool's joke there. And then, so what it does is it looks for, if I say import random, it looks for random.py here in this directory. Didn't find it? Okay, it's going to look in the next place. What is this? Python39.zip. That is the Python standard library. That is all the modules that come with Python that it can load. So it looks through that zip file. Doesn't find it there? It looks here. Doesn't find it there? It looks there. And then it keeps looking, and then it looks in site packages. We're going to talk about all these different things until at the end of the day, it gives up. And in fact, if I say here, import, blah, 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 right, it's going to give me an error there. No module named that, because it looked for that name, .py, in all of these other places. It did not find it. All right, so now this is both great and a little bit terrible. It's great in that assuming assuming a module is in the current directory, Python will find it. Assuming it is in one of the normal directories where you would want to put it, Python will find it. So what's the downside? The downside is that if you accidentally name a module that you've written in the current directory with the same name as something that's in, say, the standard library, you will never be able to load the thing from the standard library again. Two quick examples of that. I sometimes in some of my courses do an exercise of creating XML. It's a fun little exercise that we do with writing a function that produces XML. It is none of the nightmare of XML. Do not worry. It's a fun little exercise. The thing is, sometimes people will put it into a file that they call xml.py. In fact, I did this a number of years ago. I wrote xml.py, I put it into a directory, I forgot about it completely. Then, like a few months later, I tried to do import XML to do some XML handling, and nothing was working right. And it turns out that in that same directory was my old xml.py, which Python very happily was loading up. Similarly, I sometimes give people an exercise to request a random number, and they put it in random.py. Well, random.py in the current directory, when you say import random, what's it going to load? It's going to load that file. And if you're saying, wait a second, do you mean to say that a regular old Python file is just a module? Yes, it is. And we're going to see that in a little bit. Tell you what, I want to take a break, but before we do that, any questions about anything we've done so far? Give me a few seconds. I know there's a bit of a delay here. All right. So we're going to take a 5-minute break now. Let you breathe a little bit, maybe me breathe a little bit. And when we come back, what we're going to do is we're going to start writing our own little module. Now, in order to do that, I just want to warn you, we are going to want, I'm going to be using an editor. You're going to want to use an editor. I think there's a way to get Jupyter to write files, but I wouldn't necessarily want to do that. So it doesn't have to be a super fancy editor. I mean, I am, as you will see, a dinosaur, and I use Emacs. If you want to, I recommend PyCharm or VS Code if you don't have a particular favorite. But really, it doesn't matter. We're going to be writing super, super, super simple code. Just want something that knows Python, so don't worry about it too much. Let's see. Question from Matt. You just demoed AssistPath. You appear to be using BrewPython 3.9. Could you point the group to a favorite blog post regarding Python env management? Poetry, pip, Python. So I don't have a favorite post about that. I just earlier today finished recording a whole course on modules and packages, so it's a little fresh in my memory. I love poetry. Poetry is amazing and great. PyEnv, pipenv, pyflow. I actually have never heard of pyflow before. Pipenv was really hot for a while and then really out, and now apparently it's back. But pipenv is only dealing with dependencies, and it's not dealing with all the other stuff, from what I understand. PyEnv is dealing with moving into and out of virtual environments, which I must admit I don't use all that much. And I just find that poetry it's so easy to work with. If anyone wants to know what we're talking about, we're not really going to get to it too much today, but if you go to python-poetry.org, I will put this in the chat for you to look at, but python.poetry.org has everything you'd want to know about this poetry system for basically working with and then uploading things to PyPI. VSS, is there a way to influence the scope of imported variables? Well, you're not really importing variables, right? You're importing the attributes. So you are importing one variable, and it's typically going to be a global variable. So if you say, import whatever, I don't know, collections, let's say, what this is doing is, I'm defining a global variable, collections. And you're only defining one variable, everything under it is going to be an attribute. That said, if I do it inside of a function, right, so I'm going to do del collections here. I'm just going to remove the function definition. Right, so now I'm going to do this. I'm going to say def foo. I'm going to say here import collections. I'm going to say return. Let's say print collections. So watch this. This is crazy stuff. But if I say is collections defined? No, it is not. I've removed it. If I now say foo, I'm running my function. The collections module has clearly been loaded, and yet collections not defined because it was defined as a local variable. Don't do this, please. All right. So that's the only way you can influence the scope of a imported imported module, and your friends will hate you if you do that. I guess they won't be your friends anymore. All right. Let's take a 5-minute break, folks, and when we come back, we will start writing our own module and playing with it and seeing how they work. So what have we seen so far? We've seen basically how we can import a module and how we can use the things within the module. And we saw that basically we can import a module and use its data, import a module and use its functions, and whatever the module contains. What I want to do now is actually start to write a module. And we're going to start, with like simple stuff, and we're going to sort of build up and do more and more interesting things with it. And along the way, I want you to see how modules work. And that on the one hand, it's a really straightforward, simple system. There we go, those words again. On the other hand, it's very deep and allows us to do all sorts of great stuff. So how am I going to do this? Well, let's say I try to import a module. I'm going to call the module MyMod. I always like to call it MyMod. So I'm going to say here, import MyMod. And you might say, wait a second, have we defined a MyMod? And the answer is no, we have not. Now, where did Python look for this MyMod? What is it looking for? Well, it went looking in sys.path. All right, and it's a shame that I installed Rich earlier today. Fine, I'll uninstall it. So sys.path, and it looked through all these different places here, one at a time, and found that there was nothing named mymod.py. So you know what I'm going to do? I am going to define mymod.py. So this is where I'm going to drag in my editor. I'm going to drag in my Emacs window here. Oops, that's not what I wanted. There we go. All right. A little bigger so you can see it more easily. And by the way, whatever I create here is going to be in the GitHub repo as well, so you can easily take a look at it now and so forth. All right. So basically, I'm going to create a file here called mymod.py. Now, I have created the file. The file exists, and the file contains 0 bytes. It is a completely empty file. And in fact, we can see that if I look here at the directory listing, you'll see mymod.py, and you can see this column here is 0 bytes. So is this a legitimate, legal Python module? The answer is yes, 100% it is. And it has 2 great advantages over most other Python modules. Number 1, it executes really quickly. Number 2, it has no bugs. All right, more seriously, what happens if I try to import this module? So I'm going to say here, import MyMod. Okay, and look at that. It worked. No errors at all. So what names do you think are going to be defined if I say now import MyMod, so dir of MyMod? Turns out it's not nothing. You might have assumed, you might have thought that if I haven't defined anything, then nothing will be defined. Sort of makes sense, right? But no, it turns out that Python automatically defines a whole bunch of names, even in the emptiest of modules. There's something poetic there, like, even in the emptiest of modules. Okay, anyway. So what are these names here? What are these attributes that are available? So I don't want to talk about all of them because some of them are kind of esoteric, but a few of them are actually really interesting and useful. So one of them is built-ins. So you might know, if you've taken classes from me before, or if you've thought about this, talked about this, that there are 4 different places in which Python looks for variables. Those are known as LEGB, local, enclosing, global, and built-ins. And which path is MyMod created? Oh, sorry. I created MyMod in exactly the same place as my Jupyter notebook is created. Sorry, Yuan. So basically, it's in this directory: users, Reuven, courses, current O'Reilly, first steps, 2021, April 1. And in fact, if I say here, hey, MyMod, where were you defined? It'll even tell me that. So it's in the same directory as my Jupyter notebook. And thus, because Python always looks in the current directory first, it's easily picked up. If I put it somewhere else, it would not have been picked up so easily. Glad you asked that. All right, so built-ins is basically where all the built-in names in Python are defined. Things like len, sum, list, stir, dict, those sorts of things. So every module in Python, every namespace in Python has dunder built-ins defined, so it has access to those built-in names pretty easily. Dunder doc, that is the doc string. That's where the documentation for the module exists. We already saw that if we use help, we will get the doc string for it. We will talk about the doc string in a little bit ourselves. And in fact, right now, if I were to say mymod.doc, we're going to see it's nothing. It's, in fact, the none object. What if I say here, mymod.dunderFile? Well, that's going to tell me what file was it loaded from. Pretty great, huh? Okay, good. And then finally, I want to say here, mymod.dunderName. And that is my mod. So the others are really not that important to us at this point, and even day-to-day, they're not going to be that important. But these are the main attributes that Python sets for us that are really useful to have around. And we're going to talk more about these in a little bit. All right, so we basically have these names, and we can use them, and Python sets them for us, and that's kind of nice. Now let's just take a look here. Okay, so I'm now going to go here, and now I can say here. All right. So in my mod, I've now decided I actually want to have some more some more useful stuff in here. So I'm going to define a few things. I'm going to say x equals 100, y equals 10, 20, 30, z equals, let's say, a1, b2, 3. I'm even going to put in a function. Def, hello, main, turn, hello, main. Okay, so we now have in my mod, I've changed it. And now my mod contains 4 variables. And these are all global variables, x, y, z, and hello. So far, so good. So now I go back to Jupyter, and I say import my mod. And now I say dir of my mod. And what are we going to see? No changes at all. Huh? So here's the thing. When you load a module, when you import a module, Python doesn't always load it up. Python first checks to see, hey, have I already loaded this in the past? And if so, I'm not going to load it again. That would be ridiculous. Because if it were always to load it, that would lead to at least 2 problems. Problem number 1 is that if A imports B and B imports A, then you're going to get yourself into an infinite loop. And if any of you are C programmers, you know that C has this problem. And so you have to have all this if-def, if-and-def, define stuff, which I've completely forgotten about because, I haven't really used C in 20, 25 years. And look what a happy person I am as a result. So you don't want to have those infinite loops. The other thing is it would just make things much slower if every time we import something, Python needs to go and actually import it. So Python keeps track of what it has already imported. And if we've already imported something, all it does is define the name. So basically, when I say import my mod, it first checks, hey, have I already loaded this? If so, I'll just define the variable. If the variable is already defined, all right, well, fine, we'll step on the definition. Doesn't really matter. So in normal Python code, this is not an issue. In normal day-to-day Python code, okay, fine. So so we're not going to load it again. But when you're developing, when you're doing things interactively in Jupyter, this is actually a little bit of a problem. So how can we get around this? So how can we reload our module? Right now, we could just restart Python, of course, but I don't want to do that right now. So, I could do that now because I really haven't defined that much, but it's kind of annoying. So the answer is, well, in Python 2, in the old version of Python, there was actually a reload function that was always available that we could use. And one of the things they did in Python 3 was they took the stuff that was only going to be useful to developers on an occasional basis and got rid of it from the built-ins and moved it into modules. Case in point, the I'm forgetting the name right now. Reduce function, which is like the most complex function from functional programming in Python that always gives people headaches when I teach it, and I hope it's not my fault. They got rid of that from build-ins and they put it into a module. Why? Because if anyone needs it, they can get in the module. Similarly, the reload function was sort of shipped out to somewhere. Where? To import lib. That's right. There's a module that comes with Python called import lib, and it contains all the import-related functionality. And in there, import lib .reload, there is a function called reload. And if we give it a module, so this will reload the file that my mod is associated with. Right? So reload, it's basically what it does is it deletes the old value of my mod and then just it enforces that it will be loaded. So now if I say import lib.reload of my mod, and notice the module must have been loaded before. This can't work the first time. Right, so it goes and it reloads the module. We see here module my mod. So far, so good. And now I say dir of my mod. Look at that. I have hello, x, y, and z. So I have, now if I say my mod.x and my mod.y and my mod.z, I can say my mod.hello up there, and it works just fine. Right, so all these things are doing great. What happens if I just say x or y or z? Oh, totally different. X is 10 and Y is 10, 20, 30. How is X 10? Because these are different, right? This is the global variable X, not my mod.x. And this just happens because I give the same examples a lot. This is the global variable Y, not my mod.y. See why it's a good idea to see why it's a good idea to use good variable names. IS is asking, can we use del then import again instead? No, actually you cannot, because del just deletes the variable. It doesn't delete the cached version of the module that Python stores for itself. So it'll redefine the variable if you use import a second time. That's true, but it won't actually give you the new version. You need to use reload in order to get it loaded again. Okay. Let's see here. Okay. So let's see here. So we've got these things here. And of course I could say from my mod import X, from my mod import Y. By the way, can I assign to these? I still can't see extra variables after reloading. Huh. So you're saying that you did like import my mod. It was empty. And then you did a reload or, import lib reload of my mod. And you're saying that after NS, after doing the second one, you still don't see all the new stuff that you defined in my mod after that. Double check that you save the file, double check that you're working on the file in the right place. This gives you a nice hint as to what it's loading from, just in case. Okay. So can I, by the way, say my mod.x equals 98765? Yeah, absolutely I can. My mod.x, I've changed it. I've assigned to it. It's totally legitimate to assign to something an attribute in a module. Weird, maybe, but sometimes you have to do it. But have I now changed what's on disk? No, absolutely not, right? The moment I do import lib reload of my mod, that reloads it, and my mod.x is back to what it was. All right, so you can redefine things, and Python's not going to stop you. There's no way to stop you. At the same time, realize that it's only going to be temporary while things are in memory. Can you go back to my mod to see what you put in there? I missed it. Yeah, absolutely, absolutely. So here, and then by the way, if you're saying, hey, this is a module, it looks like just a simple Python program with assignments. That's right. That's absolutely right. A module in Python is just a file with a .py suffix and with definitions in it. That's basically it. How can you access a module from a different directory? So, and that's a great question. And the answer is you have to modify sys.path. There is no way for you to say, I want to load this file. It doesn't work that way. You have to make sure that sys.path is modified. And there are a few different ways to do that. One way is just to go sys.path.append because it's a list. You can do that. A better way is to put your module in one of the directories in which Python's going to be searching. And there are a bunch of ways to do that. You can even send an environment variable called Python path. And if you say Python path equals something, something, something in your environment variable, then it'll look in all those places too. XD asks, how to define a private variable in a module. So if you want a truly private variable in Python, then there's a simple fix, which is you switch to a different programming language. Because there are no private anythings in nothing private in Python. It just doesn't exist. However, you can have a semi-private variable by just giving it an underscore at the beginning of the name. So if I were to say like underscore X, then that would be considered private. We can all see it. We can all use it. We can all change it. But there's no such thing as private or protected in Python. It just doesn't exist in the language. All right. Let's actually... all right. Just want to make that a little clearer and easier for me to see what time it is. Okay, good. So basically, I can import my module. I can do a from import of my module, and it works just great. So let's actually do a little exercise here. Right? Defining a simple module. So what I want you to do now, and again, I realize that not everyone's going to do it. We'll do it right away. What I want you to do is, and then we're going to make it a little more complicated in a little bit. Right? So what I want you to do is define a module by creating a file. You can even call it my mod.py. I won't mind, right? In the current directory. Let's say, in the module, find one variable that's, that refers to data. And let's just find, one variable and one function. Import your module and use the variable and import the function. And then, I call the function. All right, so give those a shot. I'm going to put this in the chat as well, even though it's kind of ugly when I paste things. All right, give this a shot. We'll give this a few minutes, and then we'll go over it together, and then we will start to explore some more complex stuff and how it works. And by the way, if you continue to have questions or problems or whatever, keep them coming, keep them coming. How to determine the current directory of your notebook, XD? A great question. So there's what's known as magic commands in Jupyter. If you do a %pwd, get the current Jupyter directory. That'll tell you where it is. Oh, so FA asks, when must I use syspath append? So sys.path describes where Python will look for modules, right? So when you do so it's going to look in the first place, second place, third place. So what you can do is if you have like a special place where you want to put modules that's not in the regular path, you could just in the top of your program say sys.path.append at the very, very top of your program before you even do any imports. Now, I don't think that's a great way to do it, but it will work, right? At the top of your program, you just say sys.path.append wherever the directory is, and then Python will look in that directory as well. Again, I think there are better ways to do it, but that's like a quick and dirty way to do it for sure. How can you import a module in a module? Oh, can you import a module? Absolutely, you can. Absolutely. We're going to see in just a little bit what happens when we import a module, and you're going to see that you can put any code you want in a module, and that's where things get really exciting and fun. Or terrifying. I'll give us another 2 minutes or so, and then we'll go over together. Can you please? So, all right. So GP and NS are both asking similar questions. So GP is saying, how do we add a specific path to sys.path? So I'll show you. And then NS is asking, can you please tell us how and where to set Python path? Okay. So sys.path is not path. That's if you're in like, speaking of poetry. So sys.path is set automatically by Python when the language when you start up the programming language. So whenever you start up your own programming, your Python program, sys.path is set. You might not have access to it because you have to import sys first, but it is there. And it consists of the current directory, the standard places that Python is set, and then a few other things that are set. And there are a few different ways to set it. So, how can I change sys.path? So number one way is sys.path.append at the top of your program, right? Annoying, since it's not global to all programs, and kind of hackish, but it'll work. A second way to do it, a better way to do it, is set the Python on path environment variable outside of your program. When Python starts up, it'll include Python path or everything in sys.path. That's a much better way to do it. A third way, which is kind of weird, and actually I'm thinking about writing a blog post on this because I don't understand it completely, and other people don't seem to understand it completely, but you can create a file called a, I don't remember what I'm forgetting what the path something other. Let me just take a quick look. Hold on just a moment. Site packages. A moment here. Oh, as soon as I see it. Oh, PTH, that's what it is. You can create a .pth file, right? File with a PTH extension in an existing directory in sys.path, which contains assignments and directives of what Python should add. And the reason, this last one is super weird. It's used by people who create very large packages in Python and want to distribute them. You can even see here, Rich, which I installed earlier today, is doing some magic on that front, which is kind of a shame because I wanted to use Rich, but we'll do that anyway. But basically, I just heard the Python Bytes podcast. They were like, how do PTH files work anyway? And I was like, if they don't know, then I don't feel bad for not knowing it. I should learn it and then write it up. So those are your best ways to do it, as I would say. And yeah, are those kind of annoying? Yes, they are. Okay, let's go over this. So I'm just going to move this down to the bottom, and I'm going to create mymod2 in the current directory so that we can have something. So I'm actually going to go in here. I'm going to modify this and say mymod2. Is mymod2 a legitimate name? Oh, in which file do you set the Python path? The Python path environment variable is not set in a Python file. It is set in your environment outside of your Python program. So it depends on your operating system. If you're a Unix kind of person, it would be in your environment. That's why I didn't want to get into this, because it's super system specific, and it's really annoying, and it's a huge rabbit hole, I'm afraid. Name of the file, please. Bash RC, if using Bash. If you're not using Bash, that's something else. If you're on Windows, heaven help you. All right. So I'm sorry to be flip about that, but A, it's kind of fun to say about Windows, and B, I just don't know how you would do that. And I always get stuck on this point with groups because it's a really weird esoteric sort of thing, which just means even the more so I should do a YouTube video or a blog post about it. So I'm going to create a new file, and I'm going to go in here and I'm going to say mymod2.py. I'm just going to define two things. Oh, good. I'm going to define two things here. I'm going to define a function, and I'm going to define, let's say, a dictionary. So I'm going to say here, I'll say person equals first and last learner and shoe size 46. For those of you who worry like I'm like clown shoes, it's European sizes. All right, and then I can say here def, let's say here, what do I want in terms of mean? Yeah. So I can say a list of numbers and say here, return some list of numbers divided by len of list of numbers. Okay. So now what have I done in this module? I've defined a function and I've defined a dictionary. So now what I can do, I have a few different options. Option one is for me to say import mymod2. And now I can say, right, mymod2 dot mean of, I guess I'd say numbers equals 10, 20, 30, 40, 60. And if I say mymod2 dot mean of numbers, look at that. It's going to give you the mean of those numbers. I don't need to ever calculate it again on my own. Pretty great, huh? Right, and notice that in my module file is just a plain old file with a plain old definition of this variable and a plain old definition of this function. And so on the inside, in the module, everything is defined as plain old global variables. On the outside, though, they're not available as variables. They're available as attributes, right? And so it's that switcheroo that Python's doing that it took me years to even notice that it was there. But it works. It's there. MK saying, div add return x plus y. Yeah, you can do that. You can do that. Nothing wrong with that. I was trying to make it tough, but ended up with an error. I don't see anything particularly wrong with that. I don't know. Depends on what error you were getting. All right. So, and then I could also say, like, my mod dot person first. Okay. Then first. Okay. What was it called? What did I call my? Oh, yeah. My mod. Oh, my mod 2 dot person. Right, and my mod 2 dot person exercise. Right, so it actually works just fine. Right, so I can access data from there. I can import it into. I can import the module, and I have access to all this stuff. The thing is, let's say someone sees my mod 2, and they want to know how they're supposed to use it. Right, we wanted to know before how we use the random module. So how's someone supposed to know how to use this module? Well, we can say help on my mod 2. What are we going to get? Watch this. Not nothing. Not a lot, but not nothing. Look at this. Data, it shows me the definition of this dictionary. Functions, it shows me the signature of the mean function. Not too shabby for zero work on my part, huh? I love that. But how can I make this better? How can I add to this? Well, we said before that the help comes from the doc string. Indeed, if I were to say here, what's my mod2 dot under doc? Nothing. So this is what was created automatically. All right, so help is, trying to give us some, help. How can I, boost it? Well, you might know that in a function, if the first line of the function is a string, that's considered the doc string, meaning that provides us with the documentation. It's traditionally done with a triple quoted string. So I'll say here, this is the best function ever written. So great, it gets a 2-line doc string. All right, and so as long as that first line there is a string, the string does not affect the execution of the function whatsoever, but it does provide us with some documentation. And indeed, if I now say import lib reload of my mod 2, and now I say help on my mod 2, look what's going to happen. Oh, my function now has a doc string that we can read and we can look at. That's pretty great. But what about the module in general? Wouldn't it be nice to have some documentation for our module? Of course it would. And we can go back there and do that. So just as the first line of our function is a doc string, the first line of our module is a doc string. So watch what happens if I do this. I'm going to use a triple quoted string. I'm going to say first line, second line, third line, fourth line, because I am that kind of documentation writer. Okay, I'm now going to reload it. And then I'm going to look at the doc string. Look at this. And this is kind of cool. The first line is used as like a headline along with the module name. And then the second, third, and fourth lines are just there in the description. What does this mean? It means that if I want to document my module fully and nicely, I can do it here. I can say here, my mod 2, a fantastic module for learning about modules. And then second line, third, and fourth line, this is a collection of data and functions useful for people learning about Python modules. Wow, how terrific. And so now if I go back and I reload and I show the help, that's pretty great, huh? It's really starting to fill out. Oh, let's see. EM asks, I changed some case of variables in my mod, and now even though I reloaded my mod and the code only contains uppercase, why is uppercase still there? Oh, what a fantastic question. Okay, so reload, what does it do? It says we're going to get rid of any remnants of the module object. So we're getting rid of the module object, and we are also then going to load it again. We're going to import it again. But it's not deleting any previously existing variables. So when you imported it before, you defined a whole bunch of variables. Those variables still exist, right? So a module, it's not like there's a connection between, when I say here, oh, this is good. If I say here, import my mod 2, all right, now my mod 2, well, actually, if I say from my mod 2, import star, let's say I do that. Right? So now I have person and mean both are defined. And be nice person, I would say mean. All good. But if I now say, if I now change those to be in all capitalized, this variable still exists and this function still exists. The module's not associated with it anymore, but they still exist. Now, again, this doesn't happen in regular old programs because in regular programs, you're not reloading. right? Like you just don't have to worry about that so much. It's just here when we're developing that it becomes an issue. Okay, so good. Let's take a look at this. So what else can I do with my module? Well, here's the thing. Here's the funny thing that we have to think about. A lot of people, especially people who come from other languages, say, oh, I get it. A module is a bunch of definitions. So Python, like when you import the module, Python like loads that up. But wait a second, what does it mean for Python to load it up? Right? How does Python define a variable? Right? This is inside of my mod2. It is a variable. And this is a function. How do we define functions? Def needs to execute. Does that mean then that the file is executing each time we import it? Let's find out. Print. Actually, I'm going to do this in my mod. I'm just going to go back to my mod for a moment. So let's say here, print hello from my mod. Back from my mod. And that's to say, if we comment out a variable in a module, will it show up in help? That is a great question. I have to assume not. Because it's not like Python doesn't see it. All right, watch this now. We now say hello from my mod and goodbye from my mod. I'm now going to say import lib, import reload of my mod. Look at that. Hello from my mod, goodbye from my mod. It was printed. What does that prove? It proves that when you import a module, the module is executed. That's right, executed from the start to the finish. So it's not that we are loading up definitions. It's not that things are being assigned here and there. It's that the entire module is being executed, starting line 1 up to line 14 here, 1, 2, 3, 4, 5, whatever lines that we have there. And these variables are getting their assignments, not just because like we're assigning it, but because the assignment is executing. Now, it is considered extraordinarily rude to actually put a print statement inside of your module definition, right? Like you probably should not be doing that if you want to have any colleagues in the Python world. But this is a really interesting insight. So could I put a for loop in there? Yes. Could I put a while loop in there? Yes. Could I ask for input from the user? Yeah, I can do anything I want there. Don't do these things. But remember that Python is not it is a compiled language, byte compiled, but there's no way to define a variable in Python without assignment. And there's no way to define a function without def. And those require executing of code. So if you have a really long and complex module, when someone does import on it, it'll take a long time to load. There's no way around it, and it will actually define all these variables. That's why I mentioned earlier that when we do from import, we are not actually saving ourselves any execution time or memory. Because in order to, let's say I do from my mod import z, so it first needs to go through all of this stuff, define all these variables and data structures, and then only then will it make the association between our variable and that variable there. Okay, so this is like interesting, but we can make it even more interesting. Commenting variables are showing up in help for you. So I guess I'm wrong. I don't know what to tell you. It could be that it somehow notices them, or it could be you need to like delete the existing ones. I don't know what to say. I'll try to take a look at it a little later. FA, in any GitHub repository, when I found many PY files, how can I know which one to run first? So we're going to talk about that more when we get to packages, but it could be that it's just a collection of modules, right? Like it could be that there's a GitHub repository with a whole bunch of programs, and the documentation should say you want to run this thing. It could also be that it's a package in which there's going to be a particular file called dunderinit.py, which runs sort of as a proxy for everything else. And we'll see that in a little bit as well. Okay. So this is interesting. This is nice. What I want to do now is we're going to go into this much more deeply. But I want to, U1 is asking, can a module import another module inside? Oh, right. Someone asked this before, and the answer was yes. But now you can see how the answer is yes. Because if I now say, like, I don't know, import random, what does that do? What does import random do here? Well, import always says, let's look for random.py in sys.path. So it loads the module object, if the module object wasn't already loaded, and defines the variable. What kind of variable? A global variable. So now this module has random, x, y, z, and hello. Those are the global variables it has defined. And in fact, if I now say import lib, I can't spell it, save my life, import lib.reload of my mod, Watch this, dir of my mod. We have random defined now as a global variable inside of my mod, meaning it's accessible as an attribute. So I can say my mod.random or I can say random. Both are usable. And so a module can 100% import other modules. That's why I mentioned before, if A imports B and B imports A, that's fine. KS is asking, is package a collection of modules in Python terminology? Yes. KS, we're going to talk about this later, but a package is a directory in which you have multiple modules, and it's treated specially by Python as well. Okay. So let's do a more sophisticated exercise involving modules, and then we're going to come back to this whole executing of modules thing as well, and we're going to really dive deep into it. So here's what I wanted you to do. We're going to do a menu. So define a module menu.py in which you have a single name defined, a single function defined menu. And this is a very common thing to do, that you will have a function called menu in a module called menu. That leads to some weird / amusing / just, I don't know, just weird sorts of imports and naming things. And we'll talk about that in a little bit as well. So this function should take any number of string arguments. The function, when invoked, will ask the user to enter, let's say, display all of the arguments, and ask the user to choose which of the to choose one of them. If the user enters one of the one of the arguments, then it is returned to the caller. Otherwise, the user is told that this isn't, the input is invalid, and to try again. So, in other words, it'll look like this. Like if I should be able to do this, right? So I should be able to say import menu, and I should be able to say user choice equals menu.menu A and B and C. And so the user will be told choose from A, B, and C. If the user chooses A, B, or C, then that's the result that will be printed out. You don't print user chose, user choice. And if the user chooses something else, then they'll be given like a little scolding error message or whatever. Now, this involves a few possibly advanced things, right? In terms of functions that can take multiple arguments. This would be like what we call splat args. Don't freak out if this is too complex. We'll go over this together in a few minutes, and then we'll dig deeper into things. This is like as hard as the code is going to get today. All right? So give this a shot. We'll work on it together afterwards, and then we'll dig deeper into our module object and what's actually going on there. And if you have more questions or comments, whatever, keep them coming. It's great. Random is an example for import module. Yes, exactly. So sorry, SG. So basically here, I'll just show you my in my mod. So here, right? So here, my mod is importing random. And so if I import my mod then imports random. Hey, well, there's another 2 minutes or so, and then we'll go over together. And again, I realize that we're doing this fast, and it's not necessarily time for for things, but hopefully you'll get a good taste of stuff. Okay, let's go over this together and see what we can do with it. So this is an example of how we can define a module. And this is like, to get a menu. So a menu is sort of, first of all, what do I want to put in a module? Well, I want to put stuff that I'm probably going to use on a regular basis, right? I'm going to use in more than one program to try out my code. So am I going to want to ask users for inputs on a regular basis? Probably. Now, I might not want to use this kind of menu, and I don't know, calling this a menu is probably being generous to myself and, spitting in the face of menus around the world. So the first thing I have to do is create a file. So I'm going to create menu. Oops, let's do this on menu.py. By the way, do modules need to have a .py suffix? Yes. Normally, Python could not care less about what you call your files, but if you want to import as a module, it must have a .py suffix, although we'll talk about that in just a moment as well. Okay, so great. So now what am I going to put here? I'm going to say def menu. Now, again, it seems weird at first, not even always at first, to have a function menu inside of a module menu, but that's the way Python does it very often. And what am I going to take here? Well, we know that I want to take any number of arguments. I don't know how many I'm going to get. So that is something known as splat args in Python. And what that means is all of the positional arguments, all the arguments that are passed to the function are just going to be stuck into this tuple. So here, args is a tuple containing all passed arguments. And then what am I going to do with it? Well, let's start off with something really simple here. I'm going to say here, def menu, args, and I'm going to say, user choice equals input, enter your choice. And then I can say if user choice, excuse me, in args, then return user choice. And say else, well, I guess I can just do here, print, hey, user choice, not in args. Now, this is not what we want, but this is closer than what we had before, which was nothing. So there's my function, right? Well, there's a lot to do here still, but it's a good start. So now I'm going to go here, and I'm going to say import menu. That worked at least, right? It's in the same directory once again. And so now I'm going to say menu.menu of A and B and C. And it says here, enter your choice. So far, so good. And I say A. Hey, I got A back, right? That's what the function returned. And if I say here menu.menu of A and B and C. And I say Q, it says, hey, Q is not ours, end of story. We get, we got none back. Huh, okay, good start, but we're gonna need a little more stuff here. How about this? What if I say here, while true? I'm gonna do an infinite loop. Infinite loops, by the way, always good if you charge by the hour. One is asking, what does F do? F is an F string. So this is an F string, and evaluates stuff in curly braces. SF is asking, is any Python script a module too? Yes. Yes. You were starting to see that basically modules, I keep saying they're easy, and I say they're easy because if you know how to write Python in a file, bam, that's a module. All right, so now I've got while true. We get that as a choice. If use a choice in args, then we return it, meaning we break out of the loop. So now let's try this again. Oh, yeah. If you say from menu, import menu, how do you reload the module? Yeah, that's a little bit of a problem. I don't have a good answer for you. Sorry. I'm sure we can figure something out. Maybe if you do a del, that might work. I think that might work. Try, I would say in that case, del menu to get rid of the variable, and then do import menu, and then you can reload it. That's what you need. That's what you need to do. So I'm going to say here, import lib.reload of menu. Okay, and now I say menu.menu of A and B and C. I'm going to say V is not args, W, B, and we got B back. Okay, that's good. So we're basically on track. The only thing that we'd like to do now is maybe display the arguments. So I'm just going to do a little fancy footwork here, or finger work here. I'm going to say here, choices equals, watch this, choices equals, I'm going to say, /.join of sorted of args. What does that mean? It means I'm going to first take args, I'm going to sort them alphabetically. Then I'm going to join them together. I'm going to create a string based on them with slashes between the elements. And so now inside of here, I could say, enter your choice, I'll put this in parentheses, of choices. So now I'm just making it a little fancier and nicer for the kids, of course. And now I can say import lib.reload of menu. And now I say menu.menu of A and menu.menu of A and B and C. And your choice A, B, and C. And I say Q, and I say W, and I say P, and I say C, and we got that back. So I now have a function that I can use in however many projects I want, however many programs I want, via this menu, via this module. Pretty snazzy, huh? And so we can have as many functions as we want, as many data structures as we want, all that stuff. But there is something, and then if there are questions about this, please do enter them in the Q&A. But I just want to show you something more. In this directory that I've been creating here, so we have my Jupyter Notebook, that's good. We have menu, we have my mod, we have my mod 2. Oh, we're growing a whole little collection of modules here. But there's also something else that we did not create. And that's this dunder PyCache directory. What the heck is that? Well, PyCache, if we look at it, is a directory containing, look at this. It has a whole bunch of files that look sort of, kind of, like the files we created, menu, my mod, and my mod 2. So, remember I mentioned earlier, Python is actually a compiled language. It's compiled into bytecodes, and then those bytecodes are executed. It's just like Java, just like .NET in that sense, except the compiler is not nearly as smart. What can we do? Which means that if I were to import menu in the sort of a naive model of how it would work, then Python would need to go through that file, turn it into bytecodes, and then execute the bytecodes. But that whole parsing and compilation phase can take some time. And why should we do it time after time after time? So Python is smarter than that. And Python, the first time that we import a module, compiles it and stores the compiled version in this PYC file. So this PYC file is completely illegible to humans. I mean, unless, I don't know, I'm sure there are people who can read this, but certainly not me. And you can see even that our strings are in there, our variable names are in there. So it actually is everything that's necessary in order to run this and to, for this to work. But basically, this is our module in compiled form. And you'll also notice that it keeps track of the name of the module and the type of Python we're using. There's actually a bunch of different variations on Python out there. There's CPython, the one that just about everyone uses. We're using CPython 3.9. But there's also something called PyPy. And so, in fact, if I go into my, let's see. Hold on a moment. Oh, no. There we go. I'm going to tear off this tab and bring it here. So if I now go into my, I wanted to tear it off. Whoa. Not exactly what I want. Oh, goodness gracious. Oh, come on. Okay, I'll just bring this here. All right. So what you can see here is I'm in this directory, and I'm now going to say PyPy3. This is the other version of Python. I'm going to say import menu. Works just great. I'm now going to exit. I don't care. That was all. I just wanted to import it. And now if I look here, look at this. We have menu CPython 3.9 PYC and menu PyPy 3.7 PYC. So each version of Python will load the one that's appropriate for it with its bytecodes. And you can have different versions coexisting in the same directory. Does this speed up the execution? No. Does it speed up the loading of your code? Yes. Now this raises all sorts of questions. For example, does this mean that if I update my PY file, I have to recompile to get the PYC file? No. Python does that automatically. It double checks the timestamps on your file. And if the PY is newer than the PYC, it automatically steps on, gets rid of the old PYC. So you don't have to worry about that. Another question people often ask is, can I then only ship the PYC and not the PY, thus hiding my code from my customers? To which the answer is you can do that, and that will work fine until your customers discover that decompiling the bytecode is trivially easy. And so you're not hiding anything from anyone. And VS actually asks how to see the source code of the Python bytecode. Well, you can actually, there's the dis module that comes with Python. So you say import dis. And I think I can say, I think dis.dis only works on code object. Oh, file. Oh, I can actually do that. So what if I say dis.dis of, fantastic, file equals, and I've never even tried this. So I'm going to do here, under PyCache, oops, go back, under PyCache, / I'm going to say here, I'm just going to copy this file name because it's painted right. Let's see if this works. I've never tried this before. Oh, it didn't like that very much. Okay, fine. Stir has no attribute right. Okay, we need to open the file. Ha, ha, ha. Oh, it's going to write it out. Never mind. Definitely don't want to overwrite those things. I'm sure there's a way to do it, but I don't know what it is right now. Oops. All right, so basically you can, though, disassemble it if you really want. You just need to find the right tool for it. Okay. Bytecode's good. Module's good. You typically just don't have to worry about this at all. And in fact, the fact that Dunder PyCache now has the name Dunder PyCache is great. In Python 2, the PYC files were put straight there next to the PY files, which just created a huge amount of clutter, which was super annoying. Okay, we're going to take a break now, another 5-minute break. When we come back, we are going to look more into our MyMod, and we're going to see what sorts of things we can do based on the fact that it executes. I think it's going to be fun, interesting, and it's going to explain something that many of you have probably seen in Python code before. And if you haven't, you will because it's super popular. All right, so we'll take a 5-minute break now. And when we come back, more with our modules. So I'll see you guys in about 5 minutes. Definitely back now. Okay. So we have so far been seeing some interesting things here in terms of writing modules and loading modules and so forth. All that is good. But I want to return to this idea. Oh, let me hide this thing here. Return to this idea of that our module is executed line by line. And I said before, well, that doesn't mean that we want to have any sort of really weird stuff in there, like for loops or while loops, although in theory you can. But remember that we saw some of those names, those unusual Dunder names that were defined even when our module was blank. So let's just look at these again. So if I say here, dir of my mod, oops, dir of my. So we see here, right, we've got built-ins and cache and doc and so forth. And remember that I said we have Dunder name. And Dunder name is the name of the module. So let's put that in there, right? Why should I be why should I work so hard and say hello from my mod when I can just say hello from dunder name? Will that even work? I want you to remember why I'm trying this. We've seen that in a module, all the global variables we've defined, x, y, z, hello, even random, the module that we loaded, all of these that are globals inside of the module are outside of the module, right? As part, they're attributes on the module object. So dunder name, if it's an attribute on the module object, maybe it's available as a global inside the module. Remember, it's this like two-faced sort of thing where things that are globals in the module are available as attributes outside the module. So let's see. If I now say import lib reload of my mod, fantastic. It says hello from my mod, and it says goodbye from my mod. And just to remind you here, it's no longer hard-coded to say my mod. It's now saying hello from dunder name, goodbye from dunder name. So that's pretty great. I mean, assuming I actually want to print things, which I probably don't. But wait a second. Someone mentioned just before, someone asked before, does this mean that every Python program can be used as a module? The answer is yes. You might not want to do that because a lot of programs are going to just run. But yeah, and we're going to see in just a bit how we can do that. But there's something else going on here as well. Every module is also a Python program, right? So programs are modules, but modules are programs, right? If we look here at mymod.py, mymod.py is a legitimate Python program. It might be a boring Python program. It might be like not something I want to put in production, but like it works. So what happens? What happens if instead of, let's just do a terminal here. Hold on a second. There we go. I didn't want to do that. Sorry. Okay, there we go. Okay. So what happens if I then go into the current directory here where I have menu.py, and I do this. I say Python 3 menu, not menu, my mod.py. I'm going to execute my mod as if, and what's going to happen? Well, we're going to print, then we're going to have x, y, z be defined, then we're going to define our function, then we're going to print again. So really, the only thing that's going to happen is it's going to print. And sure enough, it does print. But it's printing something different. It's no longer saying hello from my mod and goodbye from my mod. Rather, it's saying hello from dunder main and goodbye from dunder main. Well, that's a little surprising, right? And that's because dunder name is actually a very special variable. It's a special value that changes its value according to what you're doing. So here's the basic idea. Remember that I was talking to you earlier about namespaces and how namespaces are super important in programming in general and in Python in particular, and that each module is a namespace. So if I have my mod and my mod 2 and my mod 3, each of those defines a variable named x. That's okay for me because I have my mod.x and my mod2.x and my mod3.x and however many more that I need. So it's just not going to be an issue. So the way that Python handles this is, so let me even write this down a little bit, right? So to give you some documentation, about dunder name. So the first, when we run Python, or let's put it this way, the first file that we run in a Python program gets dunder name. Let's even start this way. Dunder name is always defined no matter where you are in Python. This variable reflects the current namespace. That is, in which module the variables are defined. And so the first file that we run in the Python program gets dunder name, or has a dunder name value of dunder name. Now, notice that dunder name is a variable, whereas dunder, you put the quotes there, dunder main is a string. Right? Don't mix these up. It's super easy to mix these up. everything or every time we import a module, so under name is in that module as a string the same as the name of the module. So when we run mymod.py, when we run mymod.py, under name is under name. This way. But when we import mymod.py, then under name is mymod. All right, so this is a big deal. This is a big distinction because what it allows us to do is inside of our module, make decisions. This is what I want to do when I'm being imported. And this is what I want to do when I'm treated as a standalone program, right? How do I do that? How do I make such a distinction? Again, this is one of the most famous lines in all of Python. I can say here, import, I can say if, remember, can I execute things? Yes. If under name, execute things? Yes. If under name equals under main. Then and only then will I print. Remember before I said it was kind of rude to print things? Well, now I will only print things if my module is being run as a standalone program. You want to say, where is taking main string from? So dunder main, this is assigned to dunder name by Python. Python sets dunder name's value, whether dunder main or something else. But this is not something we set at all. This is something that Python sets automatically. So what this means is my module now behaves nicely when it is imported and reloaded by not printing anything, which is what we would want. But when we run it from the command line, it will print things. Let's see if that's true. So I can say here, import lib.reload of my mod, and it is silent. Whereas if I run it from the command line now, it prints hello. That's pretty great. So what you see is we can actually then create a module that acts in two different ways. Acts in one way when it's imported, another way when it's not. Now the fact is you don't want to structure your module this way. Typically, traditionally, you will have this if statement in one place in your module, and that is at the end. And at the end, you'll say, okay, after getting all these definitions, after importing, after defining data, after defining classes, after defining functions, at the end, here are the things that we want to do. So really, I can comment this out. Oh, there. Comment this out. And at the bottom, then, I have the if name equals main. Now, I can't tell you how many people think, because they come from a C programming background, think that this is somehow like the main function in a C program, that that's where things are actually going to execute. That is false. That is not the way things work. The entire file is executed from start to finish. The difference is that stuff below this line, and this if statement will only execute when the module is run as a standalone program. When it is imported, because under name is going to be my mod, this if will be false, and then it won't run. That's the basic idea here. Okay? So do you need to have this if name equals main? No. Is it very common? Yes. What does it do? Whatever you want. So what are some common uses for this line? So we can even put this down here, like, common uses. Common uses for, if main equals under main. So number one is allow, allow people, define functions and data in the module part, and then let users interact, run one of these functions interactively. So you can imagine having a module that defines a function that lets us get information from a URL. And then if you run the module manually, then it'll ask you, hey, what URL do you want to query? Another thing you can do is you can run or have the module test itself. In other words, if you import the module, then it gives you also the definitions. And if you run the module, then it runs its test for itself. You can have some, interesting, behavior, like demo what the module can do. That'll certainly work also. But there are a few different things that people could do. So you can test the module using Dungeon. Yes. So basically what you can do is you can have this if name equals main at the bottom and then run all sorts of tests on your module code, for sure. All right. So this is pretty cool, and this is pretty useful, and people use this all the time. Typically when I teach this, a bunch of people are like, oh yeah, I've seen this. I never quite understood what it does. But it works. It does something very simple because of these rules that we saw. It's because dunder name is defined automatically by Python, because it either has the name of the module or dunder main, because the entire file is executed, right? If these things weren't true, then it wouldn't work. But because of this, can we still test? Oh yeah. Oh, what if this module is calling other modular files? That's fine. So right here, right, I said import random. So I'm importing random, right? So random will have a dunder name of random. Each module has its own value for dunder name. Dunder name is defined separately in each module, in each namespace. And NS says, can we still test? Oh yeah, you can always test. You can always test. Right? That's never going to be a problem. Okay. Here's what I want to do then. So let's go back to Jupyter, I guess, for a moment. All right, so let's try this exercise. So interactive menu. So what I want you to do is add a, main line or section, let's say, to the bottom of menu.py. So if someone runs the program interactive or runs the module interactively, we should be asked which of A, B, or C we want to choose. Right? We're not going to let the user both enter the options and then print the user's response, final response once they give a valid one. All right, so the idea is now we're just going to modify the existing thing. How to test if name equals module name? You can do that, but there's no reason to, because basically if name equals main, I mean, I can't imagine why you would want to do that. But you could just say if name does not equal main, right? There are only two options. Either it's main or it's the module name. So VS, if it's not main, then it's the module name, so by definition. All right, so give this a few minutes to work on this exercise. Give it a shot. Yeah, the module name is the name of the file. Yes, exactly. But the idea is if you change the name of the file, then the module name will change also. Right, so I would strongly suggest not checking to see if the dunder name is equal to something other than dunder main. I don't think I've ever seen that. I mean, it will work, but I don't think I've ever seen it before. All right, so give this a shot, work on this for a few minutes, and then we will go over together, and then we'll dig deeper into a whole bunch of other things as well. And keep the questions coming. This is great. Yes, I'm not sure I understand it. I'd seen it in production code, but didn't understand it then. I forgot the command to do it. To do what? I'm sorry. Maybe I accidentally erased what you had written before. Just going through the Q's and A's and erasing some old ones, so I might have accidentally erased something you wrote. Hope not, though. All right, and we're going to we'll give it another 2-3 minutes, then go over it together. Your previous question in GitHub repository. Oh, your previous question. I don't know which was your previous question. I don't see it. So please re-enter it. As I said, I was doing some house cleaning and just getting rid of some old questions, and I might have accidentally deleted what you wrote. All right, another minute and we'll go over this together. And I don't know if you can hear the music, but my neighbor is a 24/7 piano player. If you cannot hear it, then good deal for you. If you know my neighbor, don't tell him I say that. All right. So let's go over this together and see what we can do. So I'm going to load up here menu.py. Menu.py, lots of M's here today. So here I have my module, which defines the menu function. So it's menu.py, and it has the menu function in it. So now I can say if dunder name equals dunder main. Again, the first one is a variable. The second one is a string. And if these are equal to each other, then I can say, for example, user choice equals menu of A and B and C. And you might be saying, wait a second, do we have to import menu? No, we're in menu. Don't we have to say menu.menu? No, because we're in menu. It's a global variable that's been defined. So menu of ABC. And then we can say here, print the user chose user choice. It's basically the same code as I had before, but now it's inside of the same file. So now if I want to, I can go back to Jupyter and I can say here, import lib reload of menu. And it works great. And I can say menu.menu of A and B and C, and it'll do the right thing. X and B, and we got B back. But I can also now go to here, the command line. I can say Python 3 menu.py. And now look at that. Enter your choice. And I say Q and X and C. And the user chose C. Fantastic. So adding that extra line there gave me, or adding this extra section here, this will only run when we call the program interactively. Under no other circumstances will it run. All right. Oh, there's new questions. Is name equal to main when you're working in Jupyter? Oh, so actually in Jupyter, so Jupyter is a weird sort of environment in that sense. So if I say, hey, what's the value of dunder name? It's going to be dunder main because it's the first thing that was run. So, I mean, if I import a module while I'm in Jupyter, well, that module will certainly not be dunder main because it's not the first thing being run. So the Jupyter Notebook itself was the first thing run. So it is dunder main, and everything you import is then going to have some other value. It's only the thing. It's only when you say Python space module name, only under this circumstance do you then get dunder main as the name. Otherwise, no. Okay, hopefully that answers that. Let's see. Okay. So this is how we can write our modules and work on them and use them and include them in various stuff. Okay, let me then just move this out of the way. Oh, I see. Okay. So all this is great, but as I hinted at before, or mentioned before, what if I'm working on a project with some other people in my group, and it turns out that one file is just not enough. And one file might not be enough for a variety of reasons, maybe for organizational purposes, right? Maybe, I have a whole bunch of things I'm going to be doing, many functions, many classes, many objects, and I want to keep them in separate files. Another possibility is that every person on the team is responsible for a different thing. Regardless, let's say my project requires 2 different files, 2 different modules. It's kind of annoying if I'm going to have to deal with these modules separately. It would be nice if I could keep these modules together, combined in some way. And that's exactly what I have, what I can do. I mentioned this earlier. This is known as a package. So I'm going to start off now just by creating a directory, and I'm going to call it my package. It is a completely 100% empty directory, nothing at all inside of it. And so now if I go back to Jupyter and I say, import my package, will that work? Yes, it will. And if I say, hey, what's my package? It's a module object. And you see here it says namespace. And the reason it says namespace is because it's completely devoid of all content. It doesn't do anything itself. It's just an empty directory. Not all modules, not all packages are like this. You'll also see if I say type of my package, it says, oh, it's a module. So yes, packages exist, and yes, packages are important, but as far as Python's concerned, really, it's a module object, right? So a module object can represent a package, a module object can represent a module. Both are totally okay. And a module object is just, as we've seen, a container for other names. If I say dir on my package, what are we going to see? The same things as we saw before that are empty. All right, so I can create a package in just an empty directory. By the way, this was not the case in Python 2. This was a change that was made in Python 3, and I think it's a good one. So now, what can I do with this? Well, I'm going to go into my package, and I'm going to create 2 files here. And I'm going to create one file called mymod.a.py. And in mymod.a.py, I'm going to say x equals 1, 2, 3, 4, 5, and y equals, let's call a set of 10, 20, 30, 40, 50. And I'm going to have def hello name is going to be returned from, it's going to be hello from mod A, or my mod A name. And now I'm going to create a second file called my modb.py. And it's going to be exactly the same, well, similar at least. I'm going to say here s equals, this is a string. And I'm going to say here t equals, let's say a tuple of 1,000, 2,000, 3,000. And then hello is going to be hello from my mod B name. So I now have in this directory 2 files, my mod A and my mod B. And they're almost identical to one another, just different, basically each has 2 variables in one function set, and the function is named exactly the same thing. The function is named hello. Now what do I do? Now how can I use this whole hierarchy of my package, my mod A and my mod B? And now I'm going to get myself out of a whole namespace pickle by restarting the backend kernel of Jupyter, meaning erasing all the names that already exist and starting to reload things on my own. So I'm going to say, okay, 0, enter, so like a nice little, what's it called, shortcut. Okay, so now if I say import my package, now I look at my package and what do I have? Actually, no change, no improvement. Let's try this a little differently. I'm going to restart the kernel. And now I'm going to say I can say from my package, import my mod A. Aha! And from my package, import my mod B. And that does not give me any errors, which gives me some hope. And now what is my mod A? It's a module object. And look how it's described to us. My package.mymod.a. But that's not how it's defined. Rather, type my mod A. We got that. Type my mod B. We got that. If I say my mod A, hello out there, That works. Hello from my mod A out there, and my mod B dot hello of out there. Hello from my mod B out there. So one of the ways in which we can load modules in a package is from import. So importing modules from a package. So option one is from package import module. This will certainly work. And then in this case, package is not defined as a variable, but module is. And that's what we have here, that I said from my package import my mod A, from my package import my mod B. My mod A and my mod A are global variables in every possible way. All right, that's option one. What is option two? All right, option two is we do it the more direct route. Option two is we say import package dot module. In this case, package is defined as a variable, and module is an attribute on that variable. Now, where have we seen that sort of syntax before? Right here, when it said module myPackage.myModA. And basically, the directory is seen as the variable. So I can say here, let's do a restart of our kernel just to clear things out. So now if I say import myPackage.myModA and import myPackage.myModB, that worked just fine. And now if I say, what's my package? Oh, it's a module. And it says, once again, it's a namespace. But inside of that namespace, we now have myPackage.myModA.hello world, right? And myPackage.myModB.hello world. And that works as well. So this is a totally fine way to do it also. But there's a third way to do it. All right. Oh, wait, sorry. Dir of my package was displayed now. Oh, great. Oh, thanks for asking. Dir of my package. Fantastic. And it now has all the names we had before, plus my mod A and my mod B. Also, if we're already looking at this, my package dot under package. That's a name we didn't look at before. It says my package. So basically, it knows that its package is my package. And what if I say my package dot my mod A dot under package? Aha! It's also set now, whereas before it was set to be none. So this is a way in which a module object demonstrates to Python that it knows that it's part of a package. It's not just floating around on its own. Okay, so this is a totally fine way for us to do it, and I don't think it's a bad thing to do. I don't think it's I think it's a totally reasonable thing to do. But there is a more complex and sophisticated way to do this as well. And what we can do in such a case is, and this is where it's going to get exciting and fun, I'm going to go back into my directory with these things. I am going to define a new file. And that new file is going to have the funny name of dunderinit.py. And I'm now going to say print running my package.dunderinit. That's all I'm going to put in here for now. Now, I told you already that print is really rude to put in these things, but I think it'll help us to understand what's going on. So I'm going to go back to Jupyter now. I'm going to restart the kernel. And now, what happens if I say import my package.myModA? And now if I say dir of my package, what do I get? Well, we see that my mod A is indeed working. And what if I say now import my package.myModB? Now it's kind of silent, right? There is my package. Okay, so on the one hand, the fact that I have that dunderinit file there means that it is executing when I import my package here and here, my mod A and my mod B. On the other hand, it is still importing and doing all the things I did before. So in that sense, the init didn't really do anything. I mean, it printed, but didn't really do anything unusual. But what happens if I restart the kernel now? And now I'm just going to say, import my package. Just that. Oh, this is new, right? Because before when I would say import my package, when it was just a directory containing some modules, before when I did it, basically, what we saw was that it just created the package object and nothing else. And if I say now, what's my package? You're going to see right? It no longer says that it's module my package and namespace. Rather, it's now saying I module my package and I was loaded from this file. In other words, let's go back to our different paradigms here. A third option is import package when there is a dunder init.py file in the package directory. In this case, dunder init.py is executed and is assigned the value of dunder file. This file can define data and functions. And it can also import other modules, including modules in the current directory with some syntactic assistance that we'll see in just a moment. It is super, super common to have a dunder init.py inside of a package directory. And what can happen then is when I load up, when I say import my package, then what's going to happen is, oh, so XD is asking, is the package just a directory holding the other packages or modules? The answer is yes, but dunder init.py changes it. When you have a dunder init.py, then you can start saying, okay, it's not just a directory holding things. Rather, it can also do some actual execution of stuff. So if I go back now to my package, dunder init.py, so what I can do here is I can say, well, it would be nice to say import my mod A and import my mod B. Okay, so let me, I'm going to go through it right now, KS. Import my mod B. So think of it this way. Let's just say that I have this package, which the package is a directory, and the directory contains two modules. Okay, so it would be nice to be able to say import my mod A, import my mod B. I don't know why they're in this order. Fine. See if I can change that. Interesting. Okay. And then I'll have it all defined. Right then, my package.mymod.a will work and my package.mymod.b will work. It'll just be loaded automatically. Lovely, right? Except it won't work. And then I'm going to try to summarize this all for you. So if I now say import my package, we're going to get an error message. The error message is module not found error. It can't find my mod A, which would seem to be a violation of one of the first rules we learned about today, namely that Python always looks at the current directory for a module. So I said import my package. When I said import my package, it started running the init.py because init.py exists. Remember, if I say import my package and it's just an empty directory, or if it's a directory containing modules, nothing executes. But if I say import my package and init.py exists, then init.py executes. However, it's still doing it based on sys.path. And the current directory is not in sys.path. So I'm going to have to use some funny footwork, fancy footwork, in order to get this to work. I'm going to say from dot import my mod A and from dot import my mod B. And what this means is when we say import my package, this file, init.py, runs. And when it runs, it then imports my mod A and my mod B from the current directory. Note that dot only works in the context of a package of, let's say, init.py for package, and only in a from import statement. I've always found this from dot to be super weird. And the reason I think it's weird is dot is not normally the current directory in Python. It's a Unixy thing or a shell thing. It's not a Python thing. Dot, come on. But special case here, special case. In a package directory, if it's init.py, and if we're in a from import, then dot means the current directory. Is it possible to see imported modules via the Python tutor visualization? The answer is no. I mean, it is, but it won't really do anything. It'll just point to like a module, and you can't create modules in the Python tutor, unfortunately. Does init.py run when you import the explicit submodules? I believe so, but let's check. Yeah, we saw that actually, I think, but let's just double check. So I'm going to first of all show the base case, then we can play with some exciting ones. So I'm now going to say import my package. What is going to happen when I say import my package? Python is going to say, do I see a directory called my package? Yeah, in sys.path? Yes. Does it have an init.py? Yes. So it's going to execute init.py. It's then going to from import my.mod A, from import my.mod B, and that should automatically give us my package.my.mod A and my package.my.mod B. And sure enough, it's running my package init, and my package of my package, and look at that. It'll have my.mod A and my.mod B. This is classic and standard to have in a package's init.py. That you have a package with lots of modules. You want to allow people to import the package in one command, not import A and B and C and D and E, each of them individually. And so what happens is you import the package imports all the modules in the current directory, or all the important ones, and then you have the whole namespace there at your disposal. Now let's just see, someone just asked this, right? What if I ask now, import the explicit submodules? I'm pretty sure they do. So I'm going to, once again, start the kernel. Now I'm going to say import my package.my.mod A. And yeah, and it runs. And now dir of my package will include my.mod A and my.mod B. Right? Doing this no longer really helps. It does anything exciting for us. So what's the upshot and the point here? The point is basically that if you have a complex, if you have one module, great, it's a file, don't worry about it. But if you have multiple modules that sort of belong together, that they should be together, then you can put them all in the same directory, and that directory is then a package, assuming, of course, it is in sys.path. If it's not in sys.path, then it's useless. Is my.mod A and my.mod B attributes of my package or separate packages when we reference it in the notebook? So as far as Python, the language, is concerned, there is no difference between a package and a module, or almost no difference, nothing worth worrying about. So basically, my package and my.mod A and my.mod B are all module objects. My package is a variable, and my.mod A, my.mod B are attributes on my package. They're all objects of type module. It just so happens that my package contains the other packages. So yes, they are attributes. My.mod A and my.mod B are attributes of my package. That is true. But they are also module objects, no less and no more than my packages. I'll do this a little bit. How can we test a package? So you can, there's nothing, when you say testing, you just typically test things like PyTest will import a module and they'll run functions that are defined in the module. So a package is a module. So you just import the package and then make sure that things are defined correctly. I don't think that should be such a problem. I don't think so. I hope not. Okay. So here, let's just check out these things. So once again, the whole point of a package is make it easier. Let me just check out these things. Make it easier to have a bunch of files together that are related to one another. And they don't have to actually interact that much, right? They don't have to. They can just, basically, they don't have to interact among each other. They can just be sort of convenient for you to access all these functions and all this functionality together. Okay, let's try a little exercise here to play with this just a tiny bit. So what I want you to do now is, exercise, turn menu.py into a package. So what I want you to do is create a new package directory. Let's call it menu stuff. Put menu.py into menu stuff and make it, make it such that if I import menu stuff, I have automatic access to menu stuff.menu and thus to menu stuff.menu.menu, meaning the function that we wrote before. All right, so work on this for a few minutes, and that'll require you to create a directory, require you to create an under init.py. I should add, by the way, that you can also define variables and define functions in dunder init.py, right? There's nothing wrong with doing that. This is a lot of flexibility that you have here, which can sometimes be dangerous. All right, so we'll give this 2-3 minutes, and then we will look at it together. I'll give us another 2 minutes, then we'll go over it together. Okay, let's go over this together. So I'm going to go and peek in Max here. So I'm going to go into our main directory here, and I'm going to create a new package. And what is it called? Meaning a new directory called menu stuff. Oh, menu stuff. Very exciting. And now I'm just going to copy menu into menu stuff. All right. So now in the menu stuff directory, I now have the menu.py module. Fantastic. But is that enough? No, that's not enough, because that would have been too easy of an exercise, and I'm not that kind of guy. So if I now say restart, I'm now going to say import menu stuff. Will this do what I want? No, because if I say menu stuff.menu, it's not loaded automatically. I could have said import menu stuff.menu. That would have worked. But what do I need? I'm going to need an init.py. So I'm going to go into the file here, into the directory. I'm going to create under init.py, and I'm going to say from.import menu. It's a little bigger, so it's easier to see. There we go, from.import menu. Now, let's see what we've got. So now in this directory, I have init.py and menu. So now if I go back and I restart the kernel, now if I say import menu stuff, silence, that's good. If I say dir menu stuff, what do I have? Menu. So if I say menu stuff dot menu of A and B and C, ta-da, it's working. A and C, and it works just fine. So this is how we can start to create a whole hierarchy. And you can have, by the way, in case it's not obvious, a package within a package. So if I want to have a subdirectory there, and each subdirectory can have its own dunder in it that imports what it wants and doesn't what it doesn't. Questions or comments? Oh, here we go. JC, is there any syntactic sugar to collapse the 3 levels into 2? Menu stuff.menu instead of menu stuff.menu.menu. Yeah. So let's see if I always get this wrong. So let's see if I can figure it out. So I should be able to say from, well, watch this. I can say from dot, I want to say here, menu stuff. Oh, I know, from menu stuff.menu, import menu. That should do it, I think. Let's just double check. And it seems kind of, well, let's get to work, and then I'll double check if I got this right. Now if I say import menu stuff. And now menu stuff.menu of A, B, C. Oh, exactly. Ta-da, and that works just fine. So basically, you can say from dot import menu, and this imports, I'm going to put this in a comment, imports the menu module into the menu variable. And here, this imports the menu function from menu stuff.menu into the menu variable. All right, so hopefully that makes it a little clearer. All right, folks. Let's take a last break for today for 5 minutes. And when we come back, we are going to talk about the standard library. We are going to talk about PyPI and pip and installing things. And that will take us through to the end. All right. So we'll be back in 5 minutes for our last hurrah of 45 minutes or whatever. All right, folks. We are back. I see here. Is anyone testing code not in Jupyter? Yeah, I'm using import OS. Oh, it's not. Yeah. Oh, that's a good idea. V, that's great. Thanks for sharing it. Okay. Oh, here we go. Oh, I see a whole lot of questions in Q&A. I didn't see. Can you have init file and submodules? Is that useful? Yeah. So absolutely. So basically, SC asks, KS asks, can we have init in submodules? So there's not necessarily something called a submodule. We would call it like a subpack. I guess it's a submodule. Anyway, if you have a package inside of a package, so each level of package can have its own dunder in it, for sure. So you can do that. I'm actually going to start sharing my screen again, so you can also see what's going on. Even though, as you can tell, I wave my hands around a lot when I'm teaching, regardless of whether you can see it or not. All right. So basically, what you can definitely have, you can have as many levels of packages as you want, and each level there can have its own dunder init to import the things you want. And remember that even if dunder init is there and only imports some of the things, some of the modules that are there, you can always access the other ones. You can just do a direct import. Okay. So KS, that was your question. Next up, we've got one from JC. Maybe off time for the rest of the group. I work in a closed facility, so I need to install pip packages manually. Could you point me to a resource for that? I will show you that, actually. Good that you ask. It's super easy. It's surprisingly easy, actually. So I'll show you that. If I don't remember, remind me, but it shouldn't be too bad. I think it would be useful to see and demonstrate import package and running entirely in Emacs. Suppose like me, you're not using Jupyter, but idle. I mean, there's like import package works the same no matter where you are. Like, I mean, sure, I can do an import package, sure. So I'll run a little, I'll do a little program here, and I'll say here, myprog.py, and I say here, import menu stuff. Ta-da! Now I've imported a package, right? Like that's basically all that happens there. It looks and feels just like importing a module, except that it's, because again, it's creating a module object as far as Python's concerned. All right, so hopefully that's makes it a little clearer. Okay. Oh, new questions. Oh, more questions. Excellent. Ian, I'm not able to get my menu stuff to work. Not sure if it's the path that's impacted. I get the following errors. Import menu stuff, menu. Oh, import menu stuff, menu. ABC, trace back. Function object has no attribute menu. Oh, okay. So this is where things get a little tricky. That's true. What's happening then is when you say import menu stuff, and then you say menu stuff.menu.menu, I'm guessing that you have in there then, hold on, let's see if I can just get it, menu stuff. So it depends on what your dunder init is doing. If your dunder init is doing it this way, the second one, then it's going to import the menu function into the menu variable. So when you say then you can't say menu stuff.menu.menu. It sort of depends what level you're going for. I was assuming that you were doing this from dot import menu, and then you would need the three-part menu stuff.menu.menu. It gets a little confusing and a little tricky. You just got to sort of double check what is being sort of, what you're referring to there. It's a little bit of trial and error, I think, unfortunately. Can you please answer, does anybody else testing code not in Jupyter? I'm not sure what you mean by testing. Like, we're not really talking about testing here. Do you mean I'm not quite sure I understand, I'm afraid. We're not dealing with testing here at all. You can put tests into, it's traditional to put tests either in a separate file or under if dunder name equals dunder main. Okay, and EM says, if this, here we go. This is the code the code is sort of hard to read in this Q&A thing in the chat. My init for menu stuff from dot import my menu. So if you're saying from dot import menu, well, it's my menu, then then you should be able to say my menu. It's hard to debug this, I'm afraid, like in this way, and I'm sorry that's the case. It's just like these tools aren't super conducive to debugging. If you want to email it to me, I'll take a look at it and hopefully get back to you the next day or two with some stuff. VS is saying, no Jupyter kernel restarting if you try to run it with Emacs. Of course not. Okay, it's not a totally different thing. It's not different. It's exactly the same thing. Basically, when you're running Jupyter, Python is running the whole time. It's the same Python running the whole time. That's why you have to restart the kernel. That's what makes Jupyter weird, right? But literally every time let me go back here for a second. Right, the program that I had here, not there. Where did I put it? I don't even know. Here we go, myprog. Every time I say Python myprog.py, it's a totally new Python environment, and this totally new Python environment, then it will load things up. That's why I have to reload the kernel in Jupyter. That's the only difference. All right, it's actually exactly the same thing. Okay, let's see if we can do it here. JC, lots of, okay. I have a package full of modules, but if I want everything in the module to be a package namespace, yeah, I guess you could say that. I guess you could then say, like, if you want everything to be a package namespace, this is a valid use of from package import star. I guess it is. Okay, I'll admit that. Fine, you got me there. Yes. Yes, JC, you got me there. And that's to say, can we test a package using unit test? Yes. We're not going to talk about that here. This is not a testing class, and we barely have time to go through the stuff that I want to. But you can use unit. The way that unit test works, I typically use PyTest, not unit test. I think PyTest is way better. I think unit test is kind of passé, and most people in the Python world are not using PyTest. But regardless, the way the tests work in PyTest is basically you import whatever module you want, and you write assertions based on the functions that are there. So you can import a package, you can import a module. whatever you want, and then you just run the assertions. So it's 100% possible to do testing on either one. That's like not that. Yeah, that works just fine. Okay. Wow, that's the question. That's great. Okay. So what I want to talk to you about now is a little bit about the standard library and then about PyPI and pip, and that should take us through to the end of our time. So we saw before the standard library. Let's take a look here. And the standard library, so back when I was a kid growing up in the U.S., I mean, for those who don't know, I live in Israel, but I've been living here for 25 years, but I grew up in the U.S., and always they would say at the end of an ad on TV for toys, they would say batteries not included, which of course meant if you managed to convince your parents to go to a toy store and buy whatever you wanted, well, then they still had to buy batteries for whatever you wanted. And one of the common phrases in the Python world is batteries included, meaning when you download Python, you get everything you need in order to do the work that you want to do. And that's thanks to the Python standard library, which is immense. So here's the documentation for it. I'm just going to scroll through it. We have lots of built-in things. These are the things you don't need to import. But then a lot of stuff that comes with a standard library, you do need to import. So for strings and regular expressions and binary data and data types and numeric stuff and functional programming and file and directory access and data persistence, right? And data compression, whether it's zip or gzip, or file formats like CSV, cryptography, operating system services and logging and curses and concurrency and networking and interprocess communication. Async I/O is very popular nowadays. Internet data, HTML, XML, internet protocols, multimedia, internationalization, TK GUIs, and then also the development tools as well. I have seen numerous polls online of how much of the standard library people know, and even the most seasoned expert Python developers maybe know about 60, 80% of it. Like the most I've ever seen is 80%. People just it's extraordinary. The standard library is huge. And so no one really knows it all, and everyone sort of hopes that they'll remember and find the things that they need. What is nice to know, though, is that it's completely standard across platforms. Meaning, if I'm using a Mac as I am, and someone else is using Linux, and someone else is using Windows, then as long as we're all using the same version of Python, in this case 3.9.2, we will all have the same modules, the same packages available to us. And so an import will work on all of those platforms regardless of what we're using. And that's really useful. Now, there are some exceptions to this. Not everything will work the same way necessarily, because there's some semantics, especially when it comes to, for example, operating system stuff like OS. But basically, if you want to work with, Python to do shell scripting to replace Bash or ZSH or something, you can do that, and you'll use the OS module quite a lot. And so you can import OS, and that's going to work. And a lot of it is actually going to be cross-platform. Some of it's not, but most of it will be. So a lot of it is just a matter of learning what's there and learning how to sort of find it and use the things that are truly going to be interesting there. So how would I do that? Well, again, assuming that it's in the standard library, I don't have to download anything, I don't have to install anything, it's just there. So for example, here we go. Let's just do collections, my favorite things here. So if I want to count how often something is there, oh, you know what? Let's do this. I'm just going to copy for a second numbers, a pen. Remember before we were looking at random numbers? So watch this. We did before. So I'm going to say here, import random, right? Random seed 0, numbers is this, range of, let's even say, 1,000. Some numbers, len numbers. Great. So I'm now getting what is the average of the number, these 1,000 random numbers between 0 and 100. All right, and I said before, very sort of blasely or very sort of, nonchalantly, oh yes, and we see because it's close to 50 that it must be a pretty reasonable distribution. Well, how do I know? Wouldn't it be nice if I could count how many of each number there are and make sure that it's not too crazy different from each other? Well, watch this. I can say import, or I can say from collections, import counter. And counter is one of my favorite data structures in Python, because what I do is I say counter of numbers. And what it does is it takes that collection, it takes numbers, the list, and it takes each of the values in the list. And the values then become keys in a dictionary. Counter is basically a dictionary. And the values in the dictionary will be the number of times each thing appears. In other words, it's going to say 49 appeared 11 times, 97 appeared 7 times, 53 appeared 20 times, 5 appeared 6 times, 16 times. You can think of it as sort of like a histogram. Okay, that's kind of nice, but what if I then say dot most common 10? And the counter object knows how to see what are the most common items there. And we see actually 53 appeared 20 times, 89 appeared 19 times. So it's not perfect, but it's pretty close there, right? And if I were to do this, say, 100,000 times. And there we go. Now we're going to see that it's all within a pretty close proximity. So that allows me to say, I think that it's a pretty good random number generator there. It does seem to be random all over the map with a good distribution. And so counter, I can depend on counter being there on every version of Python for, I don't know, the last 15, 20 years or something. But certainly nowadays it's there. So standard library, learn it as best as you can. And it is a long, long process of getting to learning. One of the nice things to do, if you're ever looking to learn more about Python, is to dive into the standard library and poke around. You will find things that are amazing. I continue to find things that are amazing in it years after starting to learn Python. If you want to give a good talk at a conference or at a user group meeting, find like a hidden gem, no Ruby puns intended, find a hidden gem in the standard library and give a talk about that. And people will be delighted because there's all sorts of stuff in there that just people don't know. So that's the standard library, and that is great for a lot of day-to-day work. It really is helpful and useful. And the fact that now you might say, why do I have to import these things? If it's in the standard library, shouldn't I just have it automatically? Well, there's a lot of stuff here. Remember, when you import, it's creating these data structures and defining these functions. It's using memory. If all of this were imported automatically when Python starts up, that would use an incredible amount of memory, and how much do we really need? So that's the distinction between built-ins and the standard library. Built-ins are the subset of the standard library that is automatically loaded into memory, and you don't need to do anything beyond that. And it's available in the Dunder built-ins namespace, or just automatically when you look for things. Other things you do need to load. And it does change over time a little bit with each version of Python, but not a huge amount. You don't need to worry about that much. And typically they give warnings before things go away, like a few years in advance. So it's not like from today to tomorrow, it's going to just disappear on you. Okay, so that's the standard library. But as amazing as the standard library is, it doesn't handle everything. And there are also some people who write modules and packages, and they don't want their things to be in the standard library. Why not? Because the standard library is only updated when a new version of Python comes out. When is that? Nowadays, it's about once a year. The current plan, as of last year, is to release a new version of Python once a year in October. And the idea is that'll give us about 6 months of testing and then 6 months of development. It means that each version that comes out is going to have fewer differences. It used to be 18 months. Now it's 12 months. So 18 months, you would have, let's just say for the sake of argument, 50% more changes between versions. So each version is going to change less, but it'll come out more frequently. And the idea is then people will be encouraged to contribute to the standard library more. At the same time, a lot of people are like, I'm not going to deal with the standard library. I just want to make this stuff available to everyone. And for that, we have, PyPI. PyPI is short for the Python Package Index. Do not confuse PyPI with PyPI. That would be ridiculous. PyPI is PYPI. PyPI is PYPY. I mean, who could possibly ever get them confused? PyPI is an alternative implementation of Python that runs faster in many ways, uses a bit more memory. It's really, really cool. It's a just-in-time compiler. So don't confuse them, even though it's super easy to do that. Anyway, the Python Package Index is the central repository for third-party, that is, say, unofficial Python packages. And I have to make an additional point here, which is the packages that are on PyPI are like a wrapper around the packages that we were just talking about. It is a very, very unfortunate historical accident that we need to work against, that what really they have on PyPI is distribution packages, meaning things that not only have what we've talked about so far, but metadata that describes what version and what it depends on and so forth. So Notice that there are almost 300,000 projects here on PyPI. If I thought, like, if you think that there's no chance of anyone knowing what's in the standard library, there's even less of a chance of knowing what's in PyPI. There's just no way. So you can search and you can poke around, and when you hear about something at a conference or when someone describes something to you, you can double check it. And there's just an incredible, incredible variety of things. Here we go, Toolbox 152. I've never heard of this before, which is not hugely surprising. I'm going to open it up. Every distribution package on PyPI has its own page. And the page says here, okay, right, how to install. We'll talk about that in just a moment. Documentation. It tells us what's the release history, right? So it seems to have, 2 minutes ago. That's pretty new, right? How often have they come out with new releases? What files do we have for downloading? We're going to talk about this as well in a little bit. And in addition, it often has links to a home page, often on GitHub. Doesn't have to be, but it often will be, because GitHub provides free hosting for open source packages. And so, like, why not? This was, by the way, in my opinion, a genius move on GitHub's part when they first did it. And you see Toolbox has 2 contributors, and they have 24 commits total. Whether that is actually a useful package or not, that's another question. So let's say I have decided, wow, I must have this Toolbox on my computer. How amazing. So how can I install it on my machine? Well, I can go to the Unix shell or to my terminal, and I'm going to use pip to install things. Now, a few points. First of all, pip is not inside of Python. It is also, so you can't run pip inside of Jupyter. You can't run pip inside inside of Emacs or inside of whatever you're running. You want to run pip from the command line. And so it's really tempting to say, oh, I'll just say pip install Toolbox. Sounds good. Now on my particular computer, I'd actually have to use pip 3, but that's like a small issue. It's increasingly common for people not to use pip directly like this, but rather for people to say Python 3 minus little m pip. What is this little m? That means import. It's basically the same as starting a Python and saying import pip, because pip is written in Python, and then it gives these additional arguments that we want to install Toolbox. Why would you want to do this? Because there are a lot of, on some computers, like on mine, for example, there are a bunch of different versions of pip running around. The one that Apple installed, the one that I installed, the multiple ones that I installed. And so this guarantees that the version of pip you're going to use is the same one that comes with whatever Python you're currently using. And so if I now say Python -3 minus m pip install Toolbox, what's going to happen? Well, pip is going to turn to PyPI and say, hey, PyPI, do you have any files for me? And here we have 2 files. There are 2 different files. One of them is the source file. You can, if you want to, download this tar.gz file, unpack it on your system, and then you go into the first directory you see and you type python setup.py install. That's what we did back in the olden times. But nowadays we have this kind of file called a wheel file with a WHL suffix. And the wheel file is fantastic. It contains all sorts of metadata, which is good. It says the name, the version of Python it works with. Does it have any specific needs? Is it only on Unix? Is it only on Windows? What kind of architecture does it work with? So for example, if your distribution package requires a C compiler, right? And there are packages that do that. If it requires a C compiler, maybe you want to package up a binary precompiled version for different architectures and different operating systems. You could do that in a wheel file. You cannot do that in a tar.gz. So wheel files have become really popular in the last few years. Oh, Chaos asks, can viruses or malicious code exist on PyPI? We will get to that in a moment. One of my favorite topics. Oh yeah, always good stuff. So now, if I go here and I check what was installed, there we go. Downloaded it, installed it, all good. Or we can hope all is good. And now if I want to, I can just go into Python. I can say import Toolbox. And there we go. Now it is loaded. And presumably, I still have a computer to use. Wow, it's taking a long time to load. Okay, so my computer still exists? Yes, good for me. So basically, that's how I can use it. And I can go to the documentation and read up on what's there, and so on and so forth. Oh, except that there isn't anything there for that. That's kind of bad, but okay, can't win them all. I see. Shades ST. Oh, I see. It looks like the documentation can be found here. And Shades ST. So it looks like it's a new owner for this package. And here we go. Now we have all sorts of content in this toolbox. Fine. And now I can just import it. So the basic order of operations, as it were, is find something that's good and interesting, download it using pip, and pip will install it. And where does pip install it? Wait a second. How is it possible for me to just load things up like that? Well, watch this. If I say here, import sys and sys.path, look what's in sys.path. There's a directory here called site packages. And if I go there, if I go to the site packages directory, so we do an LTLD of toolbox here, we're going to see that there is toolbox, and then there's toolbox 151 distinfo. This is the metadata. This tells Python like what depends on, and so on and so forth. But the real guts are here, toolbox. So basically, this site packages directory is agreed on. It's part of sys.path. So sys.path will always include it, and this is where pip installs things. So that's where the two sort of meet up. That when you install things with pip, it goes here. Oh, and someone asked before, what if we're not allowed, what if we don't have network access? I actually have a few clients where they have this problem, right? So basically, so they're working on systems that don't have internet access. How can they then install stuff? Well, pip is actually pretty smart. And pip can install not only a name from PyPI and download and install it, but if you give it a wheel file, it will install it. So what you can do then is take all the wheel files you want, just download them, download directly from PyPI, just like you can go there and do that with curl or you can just download it. It's a link here. Put that on, I don't know, USB drive or something, or CD-ROM or whatever the kids are using nowadays, and then you can move it over to whatever system you want to use, and then just do like a for loop and pip install all of them, and that should work just fine. So Chaos asks two fantastic questions. Can viruses or malicious code exist on PyPI? The answer is yes. It is rare. It is extremely rare, but it is not unheard of. If you ask me, it's going to happen more and more over time as people discover, wait, there's this like sitting duck. I am sure, no one's told me, I haven't really asked specifically, but I'm pretty sure that there are some like common scanners being run on all of PyPI. That's say when you upload things, I have to guess and assume that's going to double check like that there are no like it's going to do all the sort of automatic checks that you can run. But that's not where the real problem is. The real problem is that this is code that when you install something with pip, it is actually running Python code to install stuff on your computer. And it's running code that's in the package, which means that if I want to, I can package things up with what's called a setup.py file that will do something malicious to your computer. That is potentially terrible. And lately, just like a few weeks ago, they found a whole bunch of packages that had been uploaded that had this sort of stuff. It is a problem. It is a real problem. So how do you avoid this problem? I'll show you in a moment what's a good way to do it. But basically, you can use, that's true. You can always use sysexecutable. You can always use an exclamation point inside of Jupyter to install things. I'm not sure that's the best way to do it. I mean, I do it sometimes, but you can do it. That's true. That's true. What did I want to say? It is a problem, actually, that PyPI is so huge that there can be bad stuff in there. There is a classic answer in the world of open source that says, if we have enough people looking at it, the community will find the problems. I wish that were true. It is true, like give it an infinite time, but before that time runs out, before we find things, right, people could get hurt. So how do you figure out what you should be downloading? Like instead of just doing what I did, which is willy-nilly downloading stuff. So there's no like reviews or ratings, but what you can do is you can go to each of these pages and you can go to their homepage and say, hey, wait, how many people have actually downloaded these before? How many people have been working on it? How many versions do they have? Do not install version 0.0.1 of something that was uploaded 10 minutes ago and has one commit. So GitHub deploy. Let's say this looks interesting to me. Maybe I'll want to use it. So what's the release history? 6 hours ago, 11 minutes ago. All right, and the home page shows probably, I'm going to guess, like 10 commits or something by one person. Would I download this to my computer? Quite possibly. Should anyone else? Probably not, right? 48 commits, that's better than nothing, but it's only one person who's been working on it. I would not necessarily download this to a company computer, right? You just got to be a little careful. The more people, the more commits, the more history. It's not like a yes or no. The more likely it is to be safe, the more likely it is to be reasonable. Gutenberg PY, oh, for Project Gutenberg, that's kind of nice. So how about this? How many releases do we see here? A whole lot. How many, like if we go to the homepage on GitHub, right, we'll see. And by the way, there could be amazing, amazing stuff that's run by one person. Like, all right, but here we see 2 contributors, 65 commits. You know, it's been over years ago, right? So this has been running for a few years. Does that mean it's definitely safe? No, there's no definite in our world, folks, right? We're living in the time of COVID. There's no definite, but there is safer and less safe. The more people, the more stars, the more followers, the more time, the more likely it is that it's safe. But can people do malicious things? Here, someone just a few years ago uploaded a bunch of packages to PyPI. And remember, PyPI is distinct from the standard library. Things in the standard library are not on PyPI, but most people know that. Most people don't think about that. They uploaded, I think it was like 10, 12 packages to PyPI with almost the same names as are in the standard library. So people would be like, oh, look, that is something new. It's in the standard library. It's a little newer. I'll download and install it. Actually, the code was fine, but the installer was malicious. So that's a little problematic. Oh, excellent. Dustin Ingram is amazing. PyPI does not know about dependencies, but the metadata in the distribution does know about dependencies. It's not brilliant. It's not the best in the world, but it's actually not bad. And it's getting better and better. If you use something like, if you use Poetry, which we mentioned earlier, it will actually handle the dependencies really well. That's one of the reasons why I love Poetry so much. KS also asks, can authors remove their packages from PyPI? The answer is yes, but like it's pretty rare. I actually do that on occasion. Like I don't really have anything. I don't have anything on PyPI, but I do use it, use it to show people how they can distribute things when I do courses in that. And so I have like something on PyPI from earlier today. Oh, I know, when I was doing my thing, when I was recording my course, my recorded course about modules and packages. So do I then delete things? Yeah. Do I care? No, because it's garbage and junk. Who really removes things from PyPI? Almost no one. So should you worry about it? Not if it's a real project, not if there are a lot of people using it, right? So if it's something like Django, the odds of someone just like up and removing it from the system, basically zero. And even if someone does that, there are going to be backups and forks and everything on GitHub. So I would not worry about it very much. Something I would worry about if you're working for a commercial company is something else, which is the licensing. Everything on PyPI is open source. But the fact that it's open source doesn't mean that it's all the same license. And so basically, open source just means that you have the right to download it, install it, use it, distribute it yourself, modify it. But there are rules on what is and is not okay to do with this. So here, this module, this package, Gutenberg PY, is under the MIT license. So MIT license basically says, here's the code, do with it whatever you want, right? It's up to you. It's basically the same as the BSC license. One license that you do have to worry about, and I'm not saying this as like a value judgment, but the GNU public license, the GPL. Why do I say you have to worry about it? And let me see if I can find something that's GPL. This might be GPL, actually. So the GPL basically says, here's the code, do with it whatever you want, distribute it, change it, whatever. But, if you distribute it, whoever gets it has the same rights as you. Sounds pretty good, right? I think this was actually GPL. I just want to double check. Yeah, oh, I might do that. No, I was just totally wrong. So I don't know what's under GPL. I'm going to just look around for one or two more things. In any event, what's wrong with that? The problem is that the GPL affects the code with which it's used. So let's say you work for a company and you find a fantastic project on PyPI that will do exactly what you want. It is GPL. You include it with your code. So 1% of the final project is GPL code. The whole project is now GPL, which means that if you ever distribute your code to someone, they have the rights to ask for the source code, and they can then redistribute it without telling you, without giving you any sort of compensation and so forth. Companies that I work with do not like this idea. IST license, I've never heard of that before. Okay, doesn't really matter. Anyway, let's see, this is GPL. Oh, forget that Apache license. Okay, we're just going to assume we can find GPL stuff in here somewhere, but I was able to find it right here. Bottom line is not that the GPL is bad. The bottom line is basically that you should check with your company before you do. All right, VS is asking if I can demonstrate loading a Python module from a local file and interrupt session terminal, please. Yes, watch this. I'll go into the terminal. I will say Python 3. I will say import toolbox. I've loaded it, just like before. I did this once before, like a few minutes ago. All right, and now it loads. That's it. Right, so, oh, well, it's taking a long time. Yeah, it's taking a long time. This is like a terrible module. let me load something else here that's like better. Let's go. Oh, I see. Maybe because of, okay, let's just look through current. Here we go. Let's. Oh, no. I don't want to get wise here. Don't put all that stuff. There we go. Okay, so now I say Python 3, and I can say here, import my package. There we go. It loaded. Right, that's it. Basically, you can do it in a file. You can do it and if you want, I mean, I think I had this in like my prog as well. My prog.py. So there, that's my prog. So I can say here Python 3. I can say Python 3 my prog.py, and now that's loaded. Right. So basically, and you know that's so here I'm running a program that does an import, and here I was doing it interactively doing an import. It's exactly the same as doing in Jupyter, which is the whole beauty of Jupyter because like it's the same. Okay. Other questions or comments about this stuff? So here's what I want you to do as a little here's what I want you to do as a little exercise. Come on. These are looking a little slow here. Okay. I know it's slowing things down. So, okay, so we're going to using requests. Requests is one of the most popular, let's just use Rich. Let's use Rich instead. Rich is super cool, and I've been using it lately in my demos. Why is this taking so long? Rich. All right, so Rich is this amazing project on PyPI. So you see my syspath, sure. Really, it's not that important, but okay. Python 3, import sys.path. Your syspath will be different. Everyone's sys.path is different. Sys.path is always the current directory, and then whatever is for your installation. So looking at my sys.path doesn't help because your sys.path will be different, 100% guaranteed, unless you're also on a Mac running Python with Homebrew, and you have my particular directories. Right? If you install something with pip, it is guaranteed to be in your syspath. That's sort of like one of the nice things about installing it with pip. All right. Anyway, what I want you to do here is, so Rich allows you to do things in nice colors. So what I want you to do is, first of all, install Rich using pip. And number two, I want you to write a short program that prints that, actually, let's do this. Yeah, write a short program that uses Rich to ask the user for their name, and then prints the name in blue. Hint. I'll talk about egg files in just a moment. Hint, if you use rich.print as a function, you can then add blue and blue in the string, and the portion between those will be in blue. All right, so give that a shot now. Meanwhile, JC's question, what is .egg? So before wheel files, we had egg files, and they were just not as smart. They were not as good. Wheel files went through, they didn't include anything binary. So wheel files are where it's at now. Unfortunately, some things still use egg files. And so the reason you see this egg file here is because I installed Rich actually earlier today, or yesterday or 2 days ago as part of like preparations. And so it seems that Rich uses egg files for reasons that are completely beyond me. It doesn't even make sense to me because Rich is using poetry. Yeah, I don't get it. But like basically, if you see egg files nowadays, they basically are they're basically like legacy stuff. No one's using them anymore. All right, so give this a shot, and we'll go over together in a few minutes, and then I will show you a way to find great packages online. And then I'll answer a few more questions, and I think we'll be finishing up. Oh, wait, those are MK. I'm trying to get a simple function working, getting error. My function F809 print and so you're trying to, yeah, well, the way you define your function MK, your function requires two arguments. You need to call the function with two different strings separated by a comma. So you would say my function parentheses, like you would say basically, you need to say what is going on that's so slow? I don't know. Oop. My function of, first, last. If you do that, then it should work. Right, the error, here's a little hint. Always look at the end of the, what's it called? Of the stack trace that you get, and that makes it easier to see what's going on. I basically ignore everything in the stack trace except for the end. And I'm still alive to talk about it. Do I have any good article for setting up a setup? Yes. So actually, have I written anything about this, about poetry? I might have. Do not write your own setup.py file. Do not use poetry. It will write it for you. The poetry documentation is fantastic. Please show I turned 2 again. I couldn't do a screenshot. Okay. Yes, I'm really not sure what you're trying to get here. It's you will not have the same values here. You will not, and I'm not quite sure. Like the whole point of sys.path is that it's different on everyone's computer, and yet you can depend on it. So I'm starting to get a little impatient here. I just don't. Sure, take a look at it. I just don't get it. All right, MK, can you have optional parameters? You can, but you need to then define it that way. So you need to say the second parameter equals and then some default value. Yeah, so let me see. Did I write something about poetry? I can't remember if in the last days of Linux Journal, I wrote something about poetry or not. I think I might have been planning to, but then, let's see if I can let's see. There's a bunch of things here. I don't know what's making everything so slow. Oh, I know it's not going to be there. It would be a little bit more questions in a moment. Let's just look here. And we'll look at this another 2 minutes or so. Okay, let's see if I. I was checking through my old article for Linux Journal before it sadly died. No, it didn't write anything about it. Sorry. So I don't have any good insights. But there is there are some good talks about poetry online, and I would definitely look for those. Chaos for a setup.py file. Oh, new questions. Yes, so there's no local folder in my syspath. Actually, there is. It's right here. It'll look in the local folder there like that. Okay, I wouldn't worry about it. It's Stack Overflow issue, not working on your machine. I'm not sure what Stack Overflow has to do with this. I just don't understand. I'm sorry. All right. So let's, okay, I said that already. Okay, so let's try this here. So what I want to do is, first of all, install rich. Now, a few things about pip. If I say pip install rich. If I just do that, what's pip going to do? It's going to go to PyPI. It's going to download and install it, right? No, it is not. It's going to check first, do I have rich installed on my computer? And is there rich on PyPI? If it's already installed on my computer, it stops. It will not upgrade automatically. So right now it's going to say, I don't need to do that. Now, by the way, I already have the latest version, right? So, but if I want to, it's upgrade. It's okay. Rich is already satisfied. Now I can actually uninstall it with pip. So I can say here, it's taking a while. What's going on here? Let's just see new questions. All right, so VS, I'll take a look at this. I don't know. Is there like a problem? I really don't know. I really don't know. I've never had a problem. Let's take a look at the Stack Overflow question. But I'm sorry, I just can't answer Stack Overflow questions in this class right now. Here we go. So basically, what it said was, well, I found rich, but you already have the requirement. So I'm going to say here, uninstall rich. I'm going to just like remove it from my system, and then I'll reinstall it. And then you'll see that it'll go and download it and so forth. Actually, it doesn't need to download it because it caches things and so forth. Yes, remove it, blah, 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 blah. Okay, it's taking a long time now. I don't know what is going on with my computer here. See if I can kill off a few things. I guess it's tired. It's late at night here in Israel, so let's kill off. Maybe that'll make things a little better. All right, there we go. So now, let's see. Hello. So now I'm going to say pip3 install rich. And now it's going to go to PyPI and download and install it. Or actually, it'll just check that, In any event, if you want to upgrade it big minus U, you have to say pip install big minus U for upgrade, and then it'll do it. And you can see here now it's going to install all these things. And here are the requirements, right? So Rich says, if you're going to install me, then you have to also install this and this and this. And that actually works pretty nicely. All right. Wow, things are really slow on my computer. I have no idea why. Right, what questions? Is there a way to visualize the dependencies of the pip environment like GitLog graph? What a great idea. I know of nothing that does that, but there's got to be something, right? That would be super smart. So no idea. But I love that. Is this? Yeah, that's today here. Oh, that's interesting. Okay, there. Okay, maybe that will improve things a bit. Okay, so basically this is installed, and if I wanted to, I would use install -u. So now what I'm going to do is I'm going to write a little program that does this. So I'm going to say here, come on. All right. There we go. So I'm going to call this, come on. What the heck? All right, this is very strange. Is there anything more I could close? Back here. All right. All right. Sorry, folks. This is definitely frustrating for me too. All I want to do is like show you how to solve this, and I just want to show you one more thing, and then we'll be done. Come on, you can do it. Okay. So now I'm going to do is look for. I'm just going to create a little file. I'm going to call. Come on. There we go. Blueprint dot PY. Clever name, huh? Okay, so I'm now going to call this here and Python 3. And I'm going to say here, import rich, because I want to use the rich, what's it called? The rich module. All right. And then I can say here, name equals input, enter your name. And then I can say here, rich.print, and we'll say here, hello, blue, name, blue. You see that we have now these like all sorts of different kinds of things going on. We have the curly braces for the F string to put in the value that we got from the user. We have the square brackets, blue and blue, that rich.print will make use of. And now if we run this thing, right, and I didn't have to tell it where to install rich or anything like that. Like that's just like part of the system. So now I can run here. I can say, what am I running? I'm running Blueprint. That's what it's called. Enter my name, Ruben. Ta-da! Now my name is in blue. So basically what we were able to do here was download something from PyPI, use it, install it and use it within minutes. So, oh, good BS. I'm very happy to hear that this is working. I'm quite sure what was going on before. All right, visualize, we saw this already from KS, very good, very good. Okay, oh, the blue is navy blue and not a good diff, sub and purple. Oh, okay. I accept that. It's a very, and you can get bold and you can do all sorts of crazy stuff with rich. By the way, remember when I said that if you have a package, someone was asking what can you do with the package, and I said one thing is you can demo things. So watch this. If I say Python 3 -m rich, meaning import rich, it's going to import the package, and look what we get. I love this, by the way. Ta-da! He demos everything that it can do, or a lot of things it can do, with different colors and strike through and bold and like centering and right and different, you name it. Like it's wild. It's wild what you can do. And at the end, he even says, "Please give me money for using this," which all like good for him. Like it's really very impressive. All right. One last thing here. I just mentioned that PyPI is full of amazing stuff. But that figuring out what's amazing and good and what's amazing and potentially malicious, not always so easy. So there is a fantastic site that I've discovered in the last year or two called awesomepython.com. And what they try to do is find the good stuff for you so you don't have to sift through it and worry. And so awesomepython.com, it has a table of contents. It lists all the different sort of types of things you might be interested in. So, I don't know, configuration. And it'll list here libraries for storing and parsing configuration options. So you can just use this, and you don't need to do it yourself, and you don't need to wonder, which thing in PyPI is really going to be good. And it'll usually have a pointer to the GitHub page, sometimes the PyPI page. And you can basically, if you are worried about what is good and what is reliable, and it's not only a matter of safe, right? It's also a matter of what is being maintained, right? Someone before was asking, what if someone pulls their package from PyPI? Isn't that going to be an issue? So this actually is a great resource. And I've definitely found things and downloaded them from here. And they're not afraid to have multiple things in the same category that, for lack of a better term, compete with one another. So if you are trying to figure out, if you know something's not in the standard library, but it must exist out there somewhere, and you're a little afraid to just go searching and try and find stuff in PyPI, I would very, very strongly encourage you to try AwesomePython. All right, questions, comments, thoughts about any of this? I am at your disposal. So while people, oh, here we go, do questions and so forth. Oh, getting this one using rich. Usually, getting this one when using rich, or using this when getting rich. See nothing. Oh, you're good. Setup PY is dead. Got it. Ah, okay. Yeah, setup PY is dead. Yeah, but if we go into, let's see, let's just go into site packages, and I go into the rich directory because it's like oh, rich, it's like this. By the way, this also means that you can only have one version of a package installed at a time, right? And so that's why we have something known as virtual ends. How do you publish a package to PyPI? I would say, once again, poetry. You can say poetry publish. And now it's a little tricky in that you have to sign up with PyPI and you have to get authentication. It's definitely trickier than it should be. And it depends on your system. It's really kind of annoying, actually. But once you've got that installed, then poetry makes it great. So look at this here. Inside the rich directory, we have all these different things. And so we have init py. It's just going to load a whole lot of other stuff there. And if you look here, oh, it doesn't have it here. It's not going to have the setup py. But if I look at rich, oh, no, it's not going to be here at all. Oh, well, I thought that maybe it would have the setup PI. Anyway, you could tell that Rich was done with poetry as well. Excellent, excellent. I'm so happy to see that people were enjoying. Oh, numbers is no attribute number. I don't know. Maybe is it supposed to? Oh, it's cut and paste, cut and paste. Okay, good. Folks, thank you so much. Don't forget the GitHub repository. Oh, I guess I can unshare my screen now. You can see me again for the last few moments. The GitHub repository will continue to exist after this class. You can go and fork it, download it, play with it in all sorts of different ways. Feedback, please do fill out the survey and the feedback form. It really does help to make these classes better, more interesting, more useful in the future. We do have a whole bunch of these first steps courses. If there are others that you'd be interested in, feel free to tell us. And subscribe to my free, I do a free article about Python every week with my Better Developers list. I've got my book, I've got my YouTube channel, so you can see me. If today didn't put you to sleep, lots more where that came from. And thank you so much, everyone. Your questions were amazing. I really, really appreciate it. As I said before, it's what makes my job fun. I hope to see you again soon, and be well and be safe, everyone.
Thank you so much, Reuven, and thanks to all of you who participated today. This does conclude class. As mentioned, a survey will appear on your screen in just a moment, and we do ask that you take a few minutes before logging off to fill it out. Your feedback is extremely valuable and useful, so we do ask that you take a minute and do that for us. As a reminder, the course was recorded, and you can go back to the recording within the next 24 to 48 hours and review anything that you may have missed or need want to pay extra attention to. A link will be sent to you when the recording is available via email, and you can also access it from the course landing page. Thank you all again for attending. We hope you benefited from the training today, and we look forward to your participation in future O'Reilly online training courses. Goodbye, everybody.